and I have made it with your public.
When will you start the class, sir?
Hey, stop screen sharing, Roshin.
Roshni, just stop your whiteboard.
Roshni, stop screen sharing. Every time you are sharing your screen.
Hello.
Yeah, ma'am.
Yeah, am I
Hello?
audible?
Yeah, yes, you are.
Yes, ma'am.
Okay. Okay. Thank you. All right. So let's start. So today we'll start week 4, right? Has week 4 been done in any session previously?
No, ma'am.
It
This
will
is the
start.
first
No,
session.
ma'am. This is the first session.
Okay. All right. Let me share my screen. And please don't use the whiteboard or anything, and don't share your screens.
Ma'am, I had doubts regarding some questions in week three graded assignment. Should I ask them now, or should I wait for later?
Okay. Let's take the week 3 doubts first. Then graded assignment, right?
Yes, ma'am.
Good evening,
Okay.
ma'am.
Yeah.
I have a doubt
Which week?
from week 3 in activity question.
Activity week 3 we have discussed already. Okay. Wait. First, let me take the graded ones. Then we'll take activity doubts.
Okay, ma'am.
Okay. Is my screen visible?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah. Which question?
Ma'am, question number three.
3. This one.
Just a second. Yes, ma'am.
Okay. So
Question number
here,
three.
what is happening? E is a variable that has been assigned the value true. Then there is a while loop. This is from scores dataset, right? So iterating through all the cards, and if gender is F, so first we are checking for female. Then in the nested iteration, in the nested if, so if a card is from a female student, then we'll go to the nested if. There we will check whether their physics marks is less than 60, or chemistry is less than 60, or math is less than 60. Even if one of these is true, then we will set E to false, right? And then move that card to table 2 and continue with the next card. So it is asking that at the end of execution, when will E be true? So we know that once E is set to false, it will remain false, right? So E will only be true when. So of course, whenever we are picking card from scores dataset, obviously some cards will be from female gender. So
Yes,
the
ma'am. Ma'am,
nested if.
the doubt I have is that even I marked the correct answer to be all option number four. All female students have scores greater than or equal to 16 physics, chemistry, and maths. and that has shown to be correct answer. And what my doubt is that the value of E will change every time for each card, regardless of the whatever the value was for the previous cards. And so
See, value of
it's
E is true in the beginning, right? So once it is set to false, it will remain false. It
no,
is
ma'am.
never
I'm not.
reset to true again. Yeah, okay, ask.
Ma'am, I'm saying that it was pre-assigned to true, and for every iteration in the loop, it checks every
Hmm.
card. And
Hmm.
for every card, if anyone scores greater than less than 16 each, if any one of the subjects, it will show false. But last card in the last card, if it show if it can show true, it will print true, right? It doesn't matter if all these first 29 students got false. Sorry, if any of the first 29 students got more than 60 on all subjects.
No,
But in the
that's
last,
wrong. See, even if the last person, you're saying that if the last card that I pick is from a female student who has scored greater than 60 in all three, right?
yes, ma'am.
So even if that is true, so before her, some students might have come who are female and who have scored less than 60 in any of the subjects. So once that E is set to false, then it cannot go back to be set to true because the E is assigned the value true in line 1. And once we enter the while loop, then it is just going to iterate from line 2 to line 10. It is never going to go back to line 1 again. So once it is set to false, it will remain false.
Okay, ma'am.
So once we find such a female student who has scored, let's say, less than 60 in any of the subjects, then E is set to false. After that, even if we find a female student who has scored greater than 60 in all subjects, E is never going to be set to true again. It will remain false. Okay.
Okay, ma'am. Ma'am, can you, ma'am, I also have doubt on question number 9. Can in the same graded
Yeah, ma'am.
assignment?
Question number 9 and 10. I have doubt.
9. Okay. Let's see. This one, right? This is the question, correct? Because some people have ordered different in their graded assignments. So just check if this is the right question.
This one, this one.
Okay. So here, the following pseudocode is executed using scores dataset. What will A represent at the end of execution? So again, scores dataset. First, line 1, A is a variable that is assigned the value 0. Okay. Line 2, we are iterating through the cards in the pile. Now, uh, once the pile has more cards, so you pick the top card X. And line 4 is saying A equals to A plus is in sequence X. So this is in sequence X is
Ma'am,
what?
ma'am, I'm sorry, ma'am. Can you start again? I don't know what happened. You were not audible for the first. Can you
Okay.
explain the
Am
question
I
again?
audible now? Am I audible?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
See, I just said that in line 1, A is a variable that is set to 0. Okay. Then line 2, we are iterating through all the, like the entire pile of scores data set. So we pick the first card, let's say, which is X. And then line 4 is doing what? It is updating variable A by A equals to A plus is in sequence X. What is this is in sequence X? What is this called?
Ma'am,
What
the
is this?
return
It's a
value of
procedure.
the procedure.
Is
Membership.
this, is this the definition of the procedure or am I calling the procedure?
Calling part of the
Calling the
procedure.
procedure.
It's a function call or a procedure call, right? And this X that you're passing is the parameter. So you're passing the card that you just picked in this procedure is in sequence. Now come to line 8. Here the procedure is defined. So is in sequence the procedure which does what? See, first there is an if, outer if. It is checking whether the mathematics card of the student whose card you just picked, mathematics marks of that student is greater than physics or not. If he has scored greater in maths than physics, then we will go to the nested if and check if his physics marks is less than chemistry. Okay. If both these conditions are true, then it will return 1. If it is not true, it will return 0. Okay, this is what this procedure is doing. So basically, it will return 1 when a person has scored the highest in math, then he has scored 1 second.
Yes, ma'am.
So
So
this
then the मैम फिर कार्ड में यही बोल रहा है कि जो ऑर्डर होना चाहिए मार्क का टू रिटर्न वन इज मैथ शुड बी ग्रेटर देन केमिस्ट्री and chemistry should be greater than physics.
No, first let's check. Okay, it is saying math is greater than physics and physics is less than chemistry.
Yes, ma'am.
Okay, so math
Then
is greater than physics, and if physics is less than chemistry, do we know what is the relationship between math and chemistry?
Yeah, math is
yes,
greater than chemistry.
math is greater than chemistry.
So if physics is less
No,
than
ma'am, there is
chemistry,
not necessary.
look, this is not necessary. This is where you're making the mistake. Math can be 90. Okay, let's say the person has scored 60 in physics. So the first condition is applying 90 greater than 60. Good. Now come to the inner if. Okay, 60. Now if the person has scored 70 in chemistry, then also 60 is less than 70. So does it necessarily mean that chemistry is the highest? Or it can also happen that chemistry he has scored 100. Then also this will return true. So in that case, chemistry is highest. So either math is highest or chemistry is highest. We cannot tell which one is the highest from this information, right?
Yes, ma'am. Now I got it.
Yeah.
Yes, ma'am.
So this will return 1 when both these conditions are true. Okay, if it returns 1, then you go back to line 4 and increment a by 1. Okay, so the question is asking what will a represent at the end of execution? So this is the one number of students with lowest marks in physics out of their 3 subjects. So the only information that you can say from these line 9 and line 10 is that physics is the subject in which they have scored the lowest. I don't know which is the highest. Okay, clear? Do you need me to explain this again with an example or something?
No, ma'am.
No, ma'am, no need. It's easy
Clear,
now.
right? Okay. Next, which question? 10.
Could you
Ma'am,
please
question.
explain question 5 as well?
Yeah, okay. After 10, I'll go to 5. Okay. So 10 is saying following code is executed on words dataset. Now, what will A represent at the end of execution? So first line 1, see only variable declaration is there. So sum t, count t, b, all these are different variables. All are assigned the value 0 initially. Then while table 1 has more rows, so now we are going through the words dataset cards. Words dataset has what kind of cards? Each card has a word written on it, right? And you have the letter count, you have the part of speech, all those things. So once you pick up a card from the dataset, then in line 4, count t is incremented. So every time you're picking a card from the dataset, count is getting incremented. Next, line 5, sum is equal to sum plus x dot letter count. So sum is storing what? Sum of letter counts of the words, right? And once you have done that, then line 6, move it to table 2, move the current card to table 2 and continue. So just from line 2 to line 7, this while loop will iterate till when? Till we have run out of cards, right? Before that, we won't go to line 8. First, this while loop has to end. So at the end of the first while loop, what is count storing? What is count storing at the end of the first while loop?
Ma'am, all the cards, the number of cards.
Number of cards present in the dataset. What is sum storing?
Ma'am, the
Letter count.
letter
Sum
count.
of letter counts, right?
Yes, ma'am.
Sum of letter
Yeah.
counts of all words.
Yes, ma'am.
Hmm.
Up to this it is clear. Then line 8, see. B equals to sum t by count t, which is average letter count,
Hmm.
right? Then 9, a equals to 0. Now another variable is coming in, a, which you assign 0. Then again we go to the same while loop. Okay. Now since all the cards have been moved to table 2, so now we are picking the cards from table 2. So you pick the first card. If word ends with a comma, then if this condition is true, you go to the nested if. Then you check if the letter count is greater than b. That means if the letter count is higher than the average letter count of the entire data set. Then you increment a. So what is a going to represent at the end of execution? Number of words. Okay. It will represent the number of words which end with a comma and have letter count greater than average letter count.
Yes, ma'am.
Is there such an option? Yeah, number of words that end with comma and have letter count greater than the average letter count. Clear?
Yes, ma'am.
Anyone,
Got
any
it.
confusion?
No,
No,
ma'am, got
right? Okay. Okay, 5. Question 5. This one, right? Somebody asked this?
Yes, ma'am.
Yes, miss.
Okay. See, this is again for scores data set. Okay. Now again, A is what? A is a variable which is assigned 0. Then line 2, you are iterating through the entire data set. You pick up one card, then you assign B variable the value true. Now remember, every time we are doing a fresh iteration in this while loop, B will be reassigned the value true. Okay. If physics marks of the person whose card you have picked is greater than equal to 60 and chemistry is greater than equal to 60 and math is greater than equal to 60, that means he has scored greater than equal to 60 in all three subjects he or she has scored, then you will set B to false, otherwise B remains true. Right, this is the first if. Second if is what? If B means if B, when we will enter this block of code, when B is true or false.
True. True.
So if B is true, only then we will enter and increment the value of A by 1. So remember, all of this is happening for every card. Okay, let's say the first card I picked. Let's say the first card I picked, I first assign B to true in line 4. Okay. Then line 5, I'm checking if that person has scored greater than equal to 60 in all three subjects. Let's say he has. Okay. Then B is set to false. After that, when I come to line 8, will I increment A? No,
No,
right?
ma'am.
Because B is false now. When will A get incremented? If the person has scored less than 60 in any one of the subjects at least. Correct? Because then this line 5, this if statement will return false and we won't set B to false. So B will remain true. Only then A is getting incremented. So at the end of execution, what is A representing? Number of students
Scored less than 60, ma'am.
who have scored below 60 in at least one subject. Right? Because these are all, see, in line 5, all three conditions are connected by AND. That means even one of them, if it fails, the whole thing will fail. So even at least one subject, if he has scored less than 60, then B will be set to false. Right? I'm sorry, then B will remain true, not set to false.
Mm-hmm.
Correct.
Because ma'am, the symbol greater than equal to also implies that it will be at least one subject.
Greater than equals to means what? That it means 60 is included and greater than 60. And to violate this condition, it has to be less than 60. Okay, that person must have scored less than 60 in any one of the subjects, since they are all connected by ANDs. And AND sets to false whenever even one of the conditions are false, right? So for any person who has scored less than 60 in at least one subject, B will remain true because we won't be entering this second if. So, I mean this line 6, okay. This line 6, we won't be entering this if block. So B remains true. So which of the options is correct? Student, number of students scored below 16 at least any one subject. This is the
Second
correct
option.
Second option. Clear this code.
Ma'am, actually, in this type of question, we mostly face sort of problem in this type of question, ma'am. Earlier,
Why? What is the issue? Ask me.
ma'am,
Which part is not getting clear? Like
ma'am,
when we are setting B
initialization
to true, when it is false, that part.
in a step 4, ma'am.
Yes, ma'am. That is a bit confusing.
B is true
Okay.
and sort of confusion in after loop completed in a step 6 and B is initialized to false.
Okay.
This type of sort of problem,
See,
ma'am.
I'm going to cut out this code and I'm going to break it down. Okay. Let's do this once. Yes, this type of questions are very common. I mean, you have to be familiar or have to
Ma'am,
understand
actually,
it.
I have one doubt, ma'am. If the condition is the true, if it is a false, ma'am, it should come out of the loop, right, ma'am? So it will execute if B condition, eighth condition, ma'am. But here, if it is a true, it will execute the eighth condition.
I did not understand. See, in this particular question, when this will be false, I'm not able to shift this. 1 second. Huh? Let me open a new file. Okay, can you see this?
Yes, ma'am.
Yes, ma'am.
Okay. Now, let's just break this down a little. first line is what? A just assigned 0, right? Now, once this happens, once A is assigned 0, in the entire code when we are running this, will A again be assigned 0 at any point?
No, ma'am.
No, right? This is the first assignment and it is done. Only things which are repeated are within a loop, right? So while loop starts at line 2, ends at line 12. This entire thing will be repeated. This entire block of code will be repeated for every card that you pick, right? So let's pick the first card. Okay. Let's say first student has scored math 70, physics 80, chemistry 90. Okay. This is the first card I have picked. So when I enter the loop, read the first row in table 1. So first card I have read. Now you're setting B variable to the value true. Okay. Now you're checking in this line if their marks, if the student's marks are greater than 60 in all subjects or not. They are, see, all three subjects are joined by ands, all these three conditions. So when will this if return false? When any of the conditions fail, right?
Yes, ma'am.
That means any of them, if it is less than 60, then this if will return false. And it will return true in only one case, when all of them are above 60. Remember, not it has to be equal to or greater than 60. Right. So if any person who has scored 60 or greater than 60 in all three subjects, for them this if loop, this if code will return true, and we will enter this block of code. Okay. So for this person, tell me, is it going to return true? He has scored greater than equal to
Yes.
60 in all three, right? That means this line 5, this if statement returns true. So B will
Yes,
be
ma'am.
set to false. Up to this, it is clear,
Yes, ma'am.
everyone? Okay. Now come
Yes.
to the next line. This line. This is the second if. It is checking if B. Now, this type of statement, when if statement just has a single variable in it, I told you, what does it mean? Whether the variable's value is true or false. If the variable represents true value, then we will enter the if block. If it is false, then we will skip to the next part of the code, that is move card to table 2, this line. In this case, is B true or B false?
Be false.
So will I
False.
enter and increment A?
No, we move to
No,
table
ma'am.
2.
We'll move to
We'll
table 2
move to
and pick the next card, right? Move it to table 2, pick the next card. Now, when you pick the next card, will you again initialize B to true or not?
we will initialize B to true.
Yes.
Because this line is every time it's going to come, right? At as many number of iterations you're doing, that many number of times B is going to be assigned the value true, because it is within the loop, right? So after you pick the second card, B is again set to true. Now let's say this person has scored 15 math, 16 chemistry, and let's say 14 physics. So for this person, this if statement is going to give true or false.
False, ma'am.
True. True.
Why true?
Because their M is less than physics, mathematics marks is less than 60.
Then will it return true or false?
B will return true, ma'am.
No, I'm asking this if statement, line 5 if statement. Is the value of this if statement true or false?
False, ma'am.
False.
False.
False,
False.
right? Because both math and physics are violating. Even if only math was violating, then also it will be false, because these are joined by ands, right? So it is false. So I won't set B to false. B will remain true. Correct?
Yes, ma'am.
Next, which line
Yes,
will I
ma'am.
go to? Line 8. This line. Now here you're checking if B. Now is this true or false?
Then
False,
we will.
ma'am.
False.
Why false?
True, true.
Did I
No.
set B to
True,
false?
true.
B true, ma'am.
See,
B,
what you're doing is you are getting confused. First, focus. See each step what you are doing. Why are you getting confused? See, first B is set to true for every iteration. This
Yes.
is the only part that decides the fate of B. What happens to B? If this if statement returns true, then B will become false. If if statement returns false, then B will remain true. Right? This is just that simple.
Vice
Since
versa.
in this case, B was not set to false. That means B remained true, as it was set to true in line 4. So if B will give me true also here, If this if statement evaluates to true, then I can increment A by 1.
Yeah.
Yes, ma'am.
So at the end of execution, tell me when is A getting incremented? Whenever this if statement is evaluating to false.
If
Ma'am,
the if statement is false and B remains true, then we increment A.
ma'am, it
Right.
means step 4 and step 8 are linked with each other, ma'am.
You cannot say that because this is not for every case. If there is even a single case where like this case, first example that we took, that math 70, physics 80, chemistry 90. In that case, this if statement will evaluate to true. Then B is set to false. So only for those cases where the if statement is violated, this line 5 if statement is violated, that is, it is wrong. In that case, B will retain its true value that we set it in line 4. So when is A getting incremented? Only one case, when the student has scored less than 16 at least one subject. That is the line 5 if statement is getting violated. Correct.
Yes, ma'am.
Means, ma'am, whenever line 5 is getting
Evaluating
wrong,
to false. Yes.
yeah, yeah.
Only then A is incremented. So what are those
Oh,
cases? So line 5 will evaluate to false whenever even in one subject a person has scored less than 60. It can be more than one also. So use the word at least. So A is counting the number of students who have scored less than 60 in at least one subject. Understood?
Ma'am, one sort of confusion, ma'am. In
Yeah.
in step 8, ma'am, if B is true, then we increment A in step 9, ma'am.
Correct.
This only, ma'am.
Yeah. If B is true, only then. See, if
Okay.
B, if A, if X, this will only evaluate to true when the variable's value is true. Okay.
Yes, ma'am. Thank you, ma'am. Clear.
so ma'am, if line 5 is true, B will be false. And if line
Hmm.
5 is false, B will be true.
B will remain true. Yes.
Okay.
Because first you are assigning B the true value in line 4 for every card. Then you are checking this if condition. If it is
So,
true, assign B to false. If not, B remains true.
ma'am, for every when we see only single variable in if condition, then we can assign it as true. Otherwise,
That
we can
depends, no? What is the value of that variable? Here, like
hmm
you're checking if B.
hmm.
So you have to check that what is B's value at that point, at line 8. It can be true, it can be false. It depends on the last card you picked. But this if statement will only evaluate to true when B is true. And only then you can increment A. If B is false, then A is not incremented. You just move it to the pile and move on, pick up the next card.
Ma'am, what if B is not in while loop and B is initialized as true?
B is where?
As A. Yeah, ma'am.
Like in which line do you want B?
Means
She is
if
want
I
saying if
code
the is equals to true is in the second line.
This B equals to true is where?
Yes, ma'am.
Here.
Yes,
After
ma'am.
A equals to 0.
Yes,
yeah,
ma'am.
ma'am.
So you're saying here if I put B equal to true, right?
Yeah, ma'am.
Then B
If
equal
B
to
is
true, this once you are setting B equal to true. After that, when you enter the loop, if B is ever set to false, it will remain false. It will never be reset to true again.
means, ma'am, only first card B will be true. After this,
Yes,
we
only
when
for first
that
card B will be true. Now, if that first card violates this if condition in line 5 and B is set to false, then after that, no matter how many cards come, B will remain false. Because it is never getting out. See, once you enter a loop, code only repeats whenever it is inside a loop. Okay. Anything outside of the loop is only visited once. Every line is only visited once unless it's in a loop. Like this A equals to 0. It is assigned 0 only at the beginning. Right.
ma'am, please can you explain again?
Look.
Actually, I don't get it.
If A is 0, this is line 1.
Yeah,
Okay. Line 2, you're
yes,
saying B if I set to true here.
yeah,
Okay. Line 3, I have the while loop. Whatever
yes,
this is. And then the entire block of code without this line.
yeah.
Then what happens? First you Now start decoding this. First line A is set to 0, B is set to true. Then you enter the while loop. Okay. Then you do whatever you want. But will you ever come back to these first two lines again in your execution?
No.
Because
No,
they're
ma'am.
not inside a loop, right? That's how the flow control works. Even in that flow chart you have seen. We will visit everything once unless it's in a loop, right?
Means
So
B
in
is remaining false for 8 line every time.
depends again what your values are in the
It
cards.
depends on the first card.
So if the
Oh,
not just the first card, see, if B is set to true, okay, let's say the first card that you pick is violating this if block, this number 5 line. Okay, that means the person has scored less than 16 any one subject. Then B
hmm.
remains true, correct?
Yes.
So if B will also be true, I will add it to A, increment A.
But
But
ma'am,
say in the
if the
second
first
card,
card only violate, if first card don't
yeah,
violate the
that can
fifth
also
condition,
happen. Let's say the first card, for the first card, line 5, if is evaluating to true, that means the person has scored greater than 16 all three. Then B is set to false. I'm just saying, whenever B is set to false inside the while loop, it cannot be set to true again. It will remain false for the rest of the iterations.
yes,
That means
ma'am.
A will never be incremented again. So in this entire code, it is possible that A remains 0, right? Because even in the first
Yes, ma'am.
iteration,
If
B
the
can be
first
set
card
to false.
only, uh,
Yes.
if first card for first if condition
If
gives
for
true,
first
then B
card
will.
only, yes. If evaluates to true, then B is set to false. After that, B will never be true again. So A might remain 0. It all depends on what order your cards are in, what values they contain. Clear? This is now. Any
Yes,
confusion?
ma'am.
No, ma'am, no confusion. Now it's crystal clear.
Okay.
Ma'am, can
So
you please go to the question number 4 and 6 because there is some pseudocode generating problem. Is there?
yeah, it's graded, right?
Graded.
Okay. For
Ma'am, someone said a photo, ma'am, in chat box and asking question.
this question, this is the one, right?
Ma'am, please explain me the photo I sent in chat section, ma'am. Procedure I can't understand.
Okay, is that a part of this question or a separate question you're asking?
No, ma'am, it's a separate question. I simply asking how the procedure is running now.
Okay, you have sent the photo in the chat, right? Okay, I'll see it
Yeah.
1 second. Huh? So this question, did anyone ask? Graded 4.
Yeah, ma'am.
Yes, ma'am.
Okay. So let's evaluate this, then I will take whatever the question he has sent.
4 and
Then
6,
we'll do.
ma'am. 2.
Yeah, I'll take 6 after that. So following pseudocode is executed using shopping bills dataset. So procedure check shopping bills accepts a card Y and returns true if the minimum total bill amount of shop is greater than the average total bill amount of shop from where the Y card is generated. Okay. So check shopping bills will return true when minimum total bill amount is greater than average total bill amount. Okay. Otherwise returns false. Choose the correct code fragments to complete the procedure. Max value is what? It represents the maximum bill amount of shop Y. Okay. So here, first only we have a procedure description. There is no separate code. It's just the description of a procedure. What the procedure does is it accepts any card Y from the shopping bills dataset. Okay. This procedure will return true when the minimum total bill amount of shop, that is whatever shop this Y card is from, if the minimum total bill amount of that shop is greater than the average total bill amount of shop from where the Y card is generated, only then it will return true, otherwise it will return false. So now go through the procedure. See, check shopping bills Y is any random card from shopping bills dataset. So count is first set to 0, total amount is set to 0, minimum amount is equal to max value. Max value is what? Maximum bill amount of shop Y.
That
That means
particular shop.
the particular shop from where this Y person's card belongs, right?
Yes, ma'am.
This is a shop card or a customer card? Is there a difference? No, I think this is Y is a customer. So
Ma'am,
this
it's
is
ma'am,
one
right.
customer's
customer's,
card.
this is a
Ma'am, but
customer's card, right? Now
checking
wherever
for the
this person,
minimum bill, I think.
yeah, so max value is what? Max value is the maximum bill amount from which this person has shopped, whichever shop he has shopped from. So that maximum value we are assigning to min amount, this variable. Okay. Now while pile 1 has more cards, read the top card X from pile 1. So now you go through all the cards in the shopping bills data set itself. If shop X dot shop name is equal to Y dot shop name, that means this Y person, wherever, whichever shop he has brought things from, if that person's shop name matches with, let's say any other card in the pile, okay, any other customer's shop name, let's say X, whose card we have now picked, then count will be incremented to 1. And total amount, this variable that we assigned 0 initially, this will, excess total bill amount will be added to this total amount variable. Okay. Next, if you are checking if the X dot total bill amount, that is total bill amount of X person's card, is less than minimum amount. What is minimum amount containing? Maximum
Max
bill amount from
value.
shop of Y. Correct. So if excess total bill amount is less than that max amount, then minimum amount variable is set to X dot total bill amount. Okay. Now this if ends here. Next, this outer if closes in line 11 and we move this card to pile 2 and again start the same procedure. So at the end of execution of this while, okay, till line 13 the while loop is running, right? Line 3 to 13 the while loop is running. So at the end of execution of this while loop, what is count storing?
Count is storing
Number
number of
of cards
Number of bills
in which
that
the
belong to
X
shop
shop
Y.
name is equals to Y
Correct.
dot shop name.
So number of shopping bills that belong to the same shop from which Y has done his shopping, right?
Ma'am, here for the count, only the shop name is checking, shop name condition is checking,
Yeah,
nothing
only
else.
shop name condition is checking. That means we just want to know that let's say Y has brought his things from that big bazaar shop. Okay. Then we will count will represent what? The number of bills that are from big bazaar. Right?
Yeah,
And total amount will represent what? The total bill amount, that is total amount of shopping that has been done from big bazaar.
and ma'am, but less than the maximum value of that Y.
That will come later, na? See, total amount doesn't depend on that. This minimum amount is a separate thing. Okay. So I'm just asking at the end of execution of this first while from line 3 to line 13, count and total amount, what are they representing? That's what I'm asking. Count is representing number of
Ma'am,
cards from
from
big bazaar.
no, yes, ma'am, number of card from same shop
And
and
total amount is representing what? Total amount generated from big bazaar.
yeah,
Right?
Yeah.
This much is clear. Now every time we find a card, okay, which is from big bazaar, we check its total bill amount and we see if that is less than the maximum bill amount from big bazaar. Okay, if it is less than the maximum bill amount, then we update the maximum bill amount to that. Let's say maximum bill amount from big bazaar is 10,000. Okay, now the first person whose card I've picked, this X person, let's say he has shopped for 1,000 rupees. So 1,000 is less than 10,000. So minimum amount is what now? Just 1,000. Right. So at the end of execution, minimum amount variable is going to store what? Minimum amount of shopping that has been done from, that is the total bill amount of the person who has done minimum amount of shopping from Big Bazaar. Correct?
Correct.
So we are clear that at the end of line 13, what these three variables are meaning: count, total amount, minimum amount. Now come to line 14, average amount. Average amount is obviously total by count. So this gives us the average bill amount from Big Bazaar. Now line 15 to 17 you have to fill in. Okay, this is the question they're asking, and we have to fill it in such a way that this condition remains true. What the question is asking, that it will return true if the minimum total bill amount of shop is greater than average total bill amount. So now we have the average amount. Okay, so now check the options. If minimum amount is greater than equal to average amount, then return true. So look at the question, true if minimum total bill amount is greater That means first option is correct or wrong. There is an equal to sign.
Wrong.
So it is wrong. Second option, total bill amount is greater than minimum amount. Is this correct?
No, ma'am.
Fourth
Average
option is
amount
correct.
is not even there. Right.
Minimum
So
amount and
option 2
average
is
amount.
wrong. Third option, see, again total bill amount and minimum amount. The comparison is not between total bill amount of Y. Comparison is between average amount and minimum
Average.
amount.
Hmm.
Right. So option C is also wrong. Option D is saying minimum amount greater than average amount, then true. So this is the correct option. Now tell me who didn't understand this code and which part. Anyone?
Um, the one which is having x dot shop name equals to y dot shop name.
Hmm.
I'm not able to understand this line.
Okay. Wait. Let's just do this one more.
And ma'am, we are storing this total amount and discount without any condition, ma'am. Total
I'll
bill
explain.
amount and
See the screen? Visible?
Yes, ma'am, it is.
Word document you can see, right?
Yes, ma'am. Yeah,
Okay.
Word document.
See. Listen carefully, okay? All doubts we'll ask at the end once I'm done. See. First, line 2 is just assigning values to variable. Okay? Count variable is set to 0, total amount is set to 0. Minimum amount is a variable where we actually want to store what? This is what you have to understand first. Minimum amount is a variable where we want to store minimum bill amount from y dot shop, whichever shop y has shopped from, be it Big Bazaar, SB stores, whatever it is. We want minimum amount at the end of execution to store the minimum bill amount from that shop. This much is clear for everyone, right?
Yes, ma'am.
What is max value? Max value is storing maximum
It's like a variable.
maximum bill amount of
bill
y
amount
variable.
from y dot shop. Correct. So first, why we are starting with maximum? This thing now should be clear to you because we have done plenty of minimum and maximum questions. Whenever we want to find minimum, we assign the minimum variable some high value, right? We
Yes,
don't
ma'am.
assign it 0. We assign the highest value possible. So that's why we assign the highest value here, so that the comparison will give us the correct answer. You are trying to find an amount that is less than this minimum amount, then you will update the variable. Similarly, if we wanted to find the maximum amount, then we will do what? Assign maximum amount as 0, so
Zero.
that whenever we find a greater amount, we can update that. Right? That's why minimum amount is first assigned max value. Now come to line 3. Now line 3 to line 13 is the while loop. This iteration will first complete until there are no more cards in pile 1. Then we will go to line
Ma'am,
14.
ma'am, is there any use of line 7?
Line 7. Yes, obviously. If you
Okay.
don't have this total amount summation, then how will you get the average amount? See,
Yeah, ma'am, I understand.
first card you are picking. Okay, now Y is the parameter. So Y is some person whose card I have passed as parameter in check shopping bills procedure. Let's say this person has shopped from Big Bazaar. Okay, this person has shopped from Big Bazaar. So now everything that we do is going to be based on this Big Bazaar cards. Okay, see, read the top card X from pile 1. Now from shopping bill status set, you pick some random card X, which is the top card. If that person X has also shopped from Big Bazaar, that is, this condition is true, X dot shop is equal to Y dot shop, then count is incremented by 1 and total amount is updated to total amount plus X dot bill amount. So at the Just forget about line 8 for now. At the end of the execution of this while loop, count is going to store what? Number of bills from Big Bazaar.
Yeah, ma'am.
Is
Number
this
of bills from Big
everyone
Bazaar.
agrees to this?
Ma'am, this is saying X and Y are two persons, and the line 5 is checking that the shop name from which they have purchased something is same or not.
Yes.
Okay.
But this entire comparison will be based on Y's shop because Y is passed as parameter. Okay. X is just the random card that we have picked in this iteration. X will keep changing in every iteration, but Y remains constant. Right?
Okay, ma'am.
So count will represent number of, I'll just write it. Number
Ma'am,
of,
ma'am, it quite like the nested iteration, one iteration between one another.
these are nested if actually. Nested iteration is when you have while inside a while.
Hmm.
Okay. Number of bills from Big Bazaar because we have assumed that Y's bill is from Big Bazaar. So count will represent at the end of while loop number of bills from Big Bazaar. Clear? Any confusion till now? Okay.
No, ma'am.
Total amount is going to store what? Total bill
Amount
amount
of Big Bazaar.
from Big Bazaar. That means sum of all bills from Big Bazaar, sum of total amount from all bills in Big Bazaar, right? That total amount is stored here. Now for every card, there is also a nested if here, where you are checking what? If X dot total bill amount is less than minimum amount. So this line, why do we have this line 8 and line 9? This is so that at the end of execution, minimum amount variable will store the minimum bill amount from Big Bazaar. Right? Every time we find a lower bill amount, we update min amount. Correct? So minimum amount was
From
initially what?
line 7,
Set to max value.
from line
So
7,
let's say, yeah, what you're saying?
from line step 7, and 1 second. Total bill amount plus
Total amount is what? Total amount equals to total amount plus X dot total bill amount. That
yes,
means
ma'am. X
every
dot
card
total
that you
bill
are
amount.
picking from Big Bazaar, his total amount you are going to sum. So total amount at the end of execution of while loop is going to be total bill amount from Big Bazaar. That is sum of all bill total amounts from Big Bazaar. Right? Total amount of shopping that has been done from Big Bazaar. Clear?
Yes.
Now in this line 8 and line 9, see, let's say for the first iteration, let's say the max value was 10,000. Okay, let's say 10,000 is the highest value shopping that has been done from Big Bazaar. Now the first card X that I picked, let's say X has done shopping worth rupees only 1,000. So 1,000 is less than 10,000, right? So minimum amount is now set to what?
1,000.
1,000. Now let's say we go to pick the next X, next card, which is also from Big Bazaar. Okay, so count will be incremented, yes or no?
Yes, ma'am.
Yes.
Yes, ma'am.
Total amount will be incremented.
Yes,
Yes, ma'am.
Now come to this nested if. Let's say this was X1. Let's say the X2 person has done a shopping of 800 rupees. So now this comparison in line 8 is what? 800 is less than 1,000 or not. So what will be the new min amount?
800.
800.
So like this, if I go through the entire pile at the end of execution, minimum amount is going to store what? Minimum bill amount from Big Bazaar.
Yes, ma'am.
Everyone agrees, right?
Yes, ma'am.
Yes, ma'am.
So at the end of this line 13, we have three things. Count, which is storing number of bills from Big Bazaar. Here I've written. Total amount, which is storing total bill amount of which shopping has been done from Big Bazaar. Minimum amount is storing minimum bill amount from Big Bazaar. Now come to line 14. Average amount is a variable in which I am storing total amount by count. Means average amount is what?
Average shopping amount in Big Bazaar.
Average bill amount in Big Bazaar. Correct. Now this part of code you have to fill. What is our condition given? That this procedure will return true when? When the minimum bill amount from Big Bazaar is greater than the average bill amount. Right? So now come to the options. First option C. Minimum amount is greater than equal to average amount, but it is also including the equal condition. For equal, this is not true, right? It has to be greater than average. So first condition is false. First option is false.
Ma'am,
Yeah.
uh, sorry, ma'am, for disturbance. I just want to clear this minimum was equal to initially the maximum amount. So we are storing all the cards values which are less than the maximum amount which we consider.
Hmm. Minimum amount is going to store the minimum bill amount from Big Bazaar.
Ma'am,
Okay.
initializing to the max value, it must check the minimum value.
Why do you initialize to max value? That's the thing I said in the beginning. Whenever you want to find out minimum, you have to set the minimum amount variable to some max value from which the other values are going to be less. If you set it to 0, then will you ever get the minimum value? Because nothing will be less than 0. Understood?
Yes, ma'am.
That's why first option is wrong. Why? Because equal to is included. And your question is saying we will only return true when minimum amount is greater than average amount, not when it is equal to average amount. So first option is wrong. Second option, you don't even have to check because there is no average amount involved here. I don't care about Y's total bill amount. I need average and minimum comparison. So second and third option, you can just eliminate. Come to fourth option. Now minimum amount greater than average amount. If this is true, then return true. So this is the answer. Clear for everyone?
Ma'am, in practical, we can say how minimum amount is greater than average amount. That means 800 is greater than 1000, I think.
Minimum amount can be greater than average amount.
It depend on the value.
It depends on the entire data set. Depends how your data is skewed. There can be a minimum amount and the average can be a lot. I mean, I won't say a lot less, but it can be a little less than that, whatever the minimum is.
Okay, ma'am.
Any question from this one? Is it clear to everyone, this code?
Ma'am,
Ma'am,
once again in the
explain me
section.
the chat section, ma'am. I asked one question there.
Ma'am,
Yeah, I will take. Just tell
Ma'am,
me any
question
question
number
from this
6.
one.
ma'am, hello.
Okay. Yeah.
Ma'am, in this Y dot shop name is always fixed, no, and X dot shop name is a shop of that particular card Y.
Correct. Correct. Y dot
Okay,
shop
ma'am.
name will return true because this procedure you're running for a single card Y.
Okay, ma'am.
See,
Okay,
Y
ma'am.
is the only parameter. Okay.
Okay, ma'am.
This type of question you have to be comfortable with. This is actually very simple code. When you go to the next weeks, the code are going to getting more complicated than this. So practice more. See, don't just look at the size of the code and get intimidated. Okay, just break it down. See what is happening in each line. Don't have to take don't have to do everything at once. No, first take the first while loop, then go to the second while loop. Like this, you execute. Okay, next is okay. Someone
Ma'am,
posted
in week
something in
4,
chat.
there is many nested loop, ma'am. Nested after nested and nested in if
Nested
else
iterations are
code.
going to be there, obviously. See, in real time also, single loops are used very less. I mean, whenever you are working in real time, most problems are much bigger than the ones we have ever seen in our course. Okay, so you
More
have
than
to
2 if
optimize it.
and else are there.
Where is the one second? Yeah, chat box. Okay, Rahul Singh, you have posted the question.
Yeah, ma'am.
One second, let me check. Can you tell me the question number for this?
Ma'am,
Is it
it's a
from
bit,
graded?
yeah, ma'am, it's graded, but I can't asking answer. I just was asking the procedure, ma'am. I can't understand the procedure.
This is from
Maybe
which week?
week 4, ma'am.
Week 4 graded, so I can't
Ma'am,
discuss now.
today is already last day. Week 5 content already released, ma'am. So pressure is there.
Week 4 graded today is last date?
No, no, ma'am. Graded portion not. Week 5 content is already there. So,
No, that is
So
okay.
5.
I'm saying that I cannot discuss week 4 graded until the deadline is over.
ma'am,
Okay.
I can't asking the answer. Only the procedure section, ma'am. I asking the same question that is given in practice section, ma'am. Can you explain me
What
that?
is what do you want to know in the procedure?
Yes, ma'am. Procedure I can't understand, ma'am. Many mix option is there.
See, okay, let me share this. I won't explain too much. I'll just tell you what's happening roughly.
Yeah, ma'am. Because ma'am, today is last date for week 4 content. Not forget it, but for content. Week 5 is there.
That's okay, but until the deadline is over, not supposed to discuss graded.
Yeah, ma'am.
Week 4, I haven't even started yet. See, all these doubts are there. Right.
Ma'am, I think so. Today is not the last date of week 4 grade
No,
assignment
no,
submission.
he's saying that the content has been released for the
Content
next
last
week.
date.
That's
Go
what
and
he's
see.
saying.
Go and check your dashboard. Statics and that.
But see, the content is going to be available for the previous weeks also, no? So that's not a big deal. Here.
And
Ma'am, but
they will give the extension of for week
ma'am,
5.
but going timely is better. Thanks, ma'am.
Yeah,
Time.
that's a
Definitely.
good way.
See,
Definitely.
but we will just see what the overview of this code is, okay? And just let's check the procedure, what it is doing. Custom check is the procedure. Is my
Yeah.
screen visible?
Yeah.
Yes, ma'am.
So in custom check procedure, first you are just doing variable allocation, right? A is equal to 0, I is 1, B is false, flag is false. These are 4 variables.
Yeah.
Next, in while loop, you are checking, comparing I with the letter count of the particular word that you have passed in the this parameter of this custom check procedure, right?
Yeah, ma'am.
So I is initially 1. So 1 as how long will this while loop iterate? As long as it
Ma'am,
reaches the letter count,
letter count.
right? Once it exceeds the letter count, this will stop.
Yeah.
So where is this loop? First of all, check. See, whenever this type of question you're solving, first of all, check where each thing is ending. So while begins here, then there is an if which is beginning here, another nested if beginning here. So
Yeah.
this nested if closes here. Okay, just mark these things. This will help. Next, this outer if ends here.
93.
Okay, then there is an else block which starts here and ends in this line. Okay.
Then one more
Then
if
there
is
is,
given.
see,
While loop.
first before that while, before this if, the while itself is closing. This while that started here, it is closing here. Okay. Up to this, the while iterations are happening.
Yeah. ma'am.
Then this if will happen after the while loop closes.
Yeah. ma'am.
So what is happening inside the while loop? You are going to iterate it as many times as there are letters in P word. If ith letter is a consonant, then you do whatever is happening here. I cannot tell you this part.
Assigning
So
it to.
B is initially false. So you know that for the first iteration, what will happen? This if will it evaluate to true or false, you can say.
Yeah.
Then B is being set to true in line 22. Okay, that means if you enter
Ma'am,
this
initially
nested
B
block,
is false, and if B equal to, then initially if B equal to is check for only true condition. Na?
exactly, that's what I said, that you can understand what will happen in the first iteration. Then B is getting set to true.
Only after the first true iteration B will be updated, ma'am, I think. But
That you will know when you are solving. But then the else part, this else is not part of
and
the
then
nested if.
only one consonant will be there. Then they are asking two consonant will there consecutive. I can't understand that things, ma'am. Because A will assign
No,
to
no, no.
one
You're thinking in the wrong way. See, first of all, in the first iteration, B is what? False. That
false.
means line 19 will evaluate to false.
Yeah,
So
ma'am.
you cannot assign A to 1.
A to one.
Then B is
If
getting
the
set to true in line 22.
ma'am, if condition is true, then also we can't assign B to one because initially the condition is false, ma'am. B equal to.
That's what I said. If B is, since B is false initially, so in the first iteration, you cannot set A to 1. Not possible. Before the second iteration, A cannot be set to 1.
Then we
Okay.
can't need to check else condition. Then after checking one more if condition.
So if condition is correct, why will you go to else? You will go to else when if is not correct.
Yeah.
That means ith letter is not a consonant. Only then you will go to the else part. See, this code is very simple. If I break it down further, I'll just give the answer. So
If
we
means
try to
if
evaluate like this.
ma'am, if condition is wrong, then else condition will be updated. Na? If
Yeah,
I check
every
it,
time if is wrong, then you go to the else part. See,
if
this else is the else of this if, not this inner if.
yes, ma'am.
So every
Out
time this condition is false, that is ith letter is not a consonant, then you go to the else part and set B to false.
and ma'am, if B is initially false and else condition is true, then B will be automatically initially be false.
Yeah, so let it be false. What is the problem?
And ma'am, if we are converting that B to true, and then else condition is true,
Then it will become false again.
then again it will become false.
But will B become true? If B is true, then will you go to else? When is B getting set to true? If this outer if is true, then only B is set to true. If the outer if is true, then why will you go to else in that same iteration? In the next iteration, you might go to else.
Yeah, ma'am.
Okay.
In the outer, I am talking for the outer if iteration. If
Yeah, the
outer if
outer,
is wrong,
this else is for the outer if only. There is no nested else for this inner if. So
yes,
if the ith letter is not a consonant, then you come to else part. If it is a consonant, then you set B to true and do whatever is in here.
yeah,
Okay,
ma'am.
if this nested if is true, then do it, otherwise don't. But B will be
First,
set to true every time this if is
yes,
correct.
ma'am. If the one condition is consonant, then B will be not. If B will be not true because initially a condition is false, and after one more iteration, if there is consonant, means two consecutive consonant, then A
Don't
will
give the
be.
answer. No discussing the answers. Just
Yeah, ma'am.
understand how this is working.
Yeah, ma'am.
That's it.
Thanks, ma'am.
Okay.
Ma'am,
No
means
more.
for first iteration, B will be false always, right?
Has to be right. The first B is set to B is set to false. How will if B give you true before you set it to true? For the first iteration, it will always give false.
Means, ma'am, if B
Oh,
is means it is a universal truth statement, ma'am.
What? I
Hello?
didn't understand.
Ma'am, if in condition no nothing given, if B only in bracket, if and bracket only B is given, it means universal truth.
Why inverse of true? This if B will evaluate to true only when B is
Because
true.
ma'am, it is not taught any part of the course, and I asked to check GPT, and there you
No,
are
no, no.
saying it is a
I
universal
have
truth, ma'am.
I have said this plenty of times. Other people will know, I hope, that I have said this plenty of times in the previous sessions that whenever we write if X, if A, if B, this if
Yes.
statement is true when the variable itself is carrying a true value. Have I not said this before? Do not
Yes.
go to ChatGPT. No, that is going to give it, that is not a reliable source. Obviously, you ask
Yeah,
me
ma'am, I
whatever
know
question
that
you ask.
not reliable, so it many times give the wrong answer, but I try to learn the logic and
Okay,
not the
this is
answer.
clear now, right?
Yeah,
So
ma'am.
if X will be true when X is true.
Yeah,
Clear?
thank you.
Now, which is the next question? Graded 6. This is the last question I'll take. Okay, I have to start week 4 content. Otherwise, you only will suffer. Please check. This is the question you're asking. Whoever asked this.
Yeah, ma'am.
Okay. So following pseudocode is executed using scores dataset. At the end of execution, variable count captures the number of students whose total marks are more than the average of total marks of entire dataset, but have scored below subject average in any two subjects. So assume that average T holds the value of average total marks in the entire dataset. Okay. Similarly, variables average PCM holds average physics, chemistry, math marks from the entire dataset. So we have to just choose the correct code fragment. So most important is the first two lines. It is saying, first of all, from scores dataset, and at the end of execution, what should count capture? Number of students whose total marks are more than average total marks. That means whose total marks are more than average T variable, correct? Which variable is storing average total marks? Average T.
Yes, ma'am.
Yes, ma'am.
So we are going to count is going to capture number of students who have scored greater than average T in total marks, and what is the other condition? But have scored below the subject average in any two subjects. That means he has scored either less than average P average C, or average P average M, or average C average M, or average whatever conditions are there. Okay,
Yes,
that
ma'am.
means and
Any
any
two,
combination of this PCM average, any two, he has scored below.
if condition it to true.
So now check the code. These are very simple questions. The reason why you're asking this is because you are not evaluating the code properly. You're not going line by line. You're seeing the thing as a whole. Just break it down. See, first count is 0. Then while table 1 has more rows, that means every scores data set card you're picking. First, in every iteration, see, A, B, C, D. These are getting initialized every time we pick up a new card, right? Since they are inside the while loop. So every time you pick up a new card X, line 4 will be evaluated. Every time they are going to be set to these values A, B, C, D. All are set to false. It's like getting a fresh page every time you pick up a card. Then line 5 is checking whether total is greater than average T. See, this is even easy question. Why? Because you are not even having to write the code for calculating average T, average P, average
It
C,
is
average M.
looking
Everything
tough
is
because
given.
of many variables is there. 6 to
Yeah,
9
but see, it
variables.
is a very easy code. All the
It's
average values
very
are
easy
also
question.
available to you.
Any
So
tool
if X dot
if
total
you
is
can
greater
take.
than average T, okay. If X dot total is greater than average T, then A is set to true. If the maths marks is less than average math and physics marks is less than average physics, that means if the student has scored less than average in maths and physics, then B is set to true. Again, what can be one more condition? What can be one more possibility that the person has scored less than average in physics and chemistry? Then C is set to true. If the person has scored less than average in chemistry and maths, then D is set to true. If any of B, C, D are set to true and A is set to true, that means that is the person for whom count should be incremented. Yes or no? This first condition has to be correct.
First condition must have to true and any
So
of
A
these
has to
three
be true
conditions
and
true.
any of B, C, D has to be true.
Yeah.
Right?
Ma'am,
If more than
here we applying the OR operation instead of AND.
yes, see, all of these ifs are not nested. They're all individual ifs. Okay. So if let's say for a person A is true, B is true, but we see that C is also true, then for that person will I increment count? He has scored less than average in all three then.
No, ma'am, not true.
No, ma'am,
Only
only
for
two
any.
subject.
Okay. So this code, whatever we have to fill in from line 17 to line 19, we can understand that for this, for count to be incremented, the if condition should be A is true and any of B, C, D is true. Any one, right? A is true is constant and
Ma'am,
any of
it is
B or
asking for
C or D.
at least one subject. Means
Is
average
that
less.
so? Read the question. But have
Any two
scored below
subject.
average in any two. It is clearly mentioned.
Any
Any
two.
two,
Yeah, ma'am,
not
got
at least. That means A has to be true and any of B, C, D has to be true. Any one, not more than one. So now check the options. You just have to pick the right option where this is getting satisfied. That A and any of B, C, D.
any of B,
So
C.
So
if
option
the
1 will
in
be
the
correct.
first option, let's evaluate still. If A is true, fine. B or C or D. So let's say all B, C, D, all three of them are true. Then also this will evaluate to true. But is that correct? If all of B, C, D are true, that means person has scored less than average in all three subjects. Then also first option will evaluate to true and increment count. But is that a correct way?
No, ma'am.
No, ma'am.
No, ma'am.
No.
So it is wrong. That's why I say evaluate the options. Don't just look and mark the answer. Evaluate every option. If second option, if A and B and C and C and D and D and B. So
No, ma'am.
again
It's a
take that
no.
same thing. If B, C, D all are true. For that also it is incrementing count. Again this is wrong. Right? So it should be true for like this. Average M, average P. Okay. For this B is true and A is true. If these two are true and the others are false. Right? That means chemistry, this person has not scored less than average. Then this person should be incrementing the count. So is that happening in second option? Just check the one
No,
case
ma'am.
where all three are true. For that is the count getting incremented. Yes, here also the count is getting incremented even if B, C, D all are true.
Yes.
So this is also not correct. Third option. If A or B and C. Okay. If A or B and C, or C and D, or D and B. I think there is something wrong with this. What have they given in the answer? A and B or C or D.
First option.
But how is this correct? First option should not be the answer. If A is true and B, C, D all are true, then
Ma'am,
also the OR will give true.
ma'am, with A only one condition will be mixed na at a time. That's why you mixing all
That's what I'm
condition at the
saying, that
same time.
OR
Ma'am,
means what?
if A is true, then it will not check the other condition. If B will
No,
be
if
true,
A is true, if A is true, then it will have to check that whether one of B or C or D are true,
true, yeah, ma'am.
right? So if
Please
any two of these variables are
post
true, then also OR is going to give true, because OR gives true whenever one or more than one are true, right?
So, ma'am, you
Ma'am,
want to
it
say
is
that
checking for
if
only two
B,
conditions.
C, and D both all of them are correct, then
Hmm.
the statement will be wrong.
I'm saying let's take this case where a person has scored greater than the average, total average. Okay, this is not even possible, right? So if a person has scored less than average in all subjects, then he cannot have scored greater than average in total, right? It is not even
Yeah,
possible.
ma'am.
Yes, ma'am.
This condition.
That's why this is working. Okay. Yeah, then this first option is correct. Because if the person has scored greater than average in total, then it is not
Ma'am,
possible that he has scored less than average in all three. So any
at
one only
least,
will be true.
yeah, ma'am.
But ma'am,
Because if
in
you
two
take B or
subject,
C or C or D, yeah, that's what I'm saying. See, if you take B or C or C or D or B or D, any of these two to be true, okay, that means the person has scored less than average in all three. See, if B and C are both set to true, that means person has scored less than average in maths, physics as well as chemistry, right? Correct or not?
yes, ma'am.
But if he has scored less than average in all three, then is it possible he has scored greater than the average total?
No, ma'am, it
That
will
will
be
never
less
be a
than.
true case, right? It will only be true when he has scored, it can be true when he has scored less than average in any two. That means only any of B, C, or D will be true. And A is true. So there is only one case when A can be true. When any of B, C, or D are true, not more than one of B, C are true at the same time. If BC is true at the same time, or CD is true at the same time, or BD is true at the same time, or all three are true at the same time, it means that the person has scored less than average in every single subject. If a person has scored less than average in every single subject, how can he score greater than the average total? So this first option will be correct because A will be true and either B or C or D will be true. Clear to everyone? I don't
Yes,
think so.
ma'am.
Tell me, what is the,
Yes,
who
ma'am.
has a doubt? Tell me. This is a good question. Who has a doubt? Anyone?
Ma'am, not in this question.
No, ma'am, I was doubting question.
This
Now,
question?
now it's clear.
Okay. The main thing that you have to realize is that if a person scores less than average in all three, then he cannot score greater than average in total. That's the
He,
main thing.
he have to score at least one subject.
Yes. Because something has to make up for that loss in the other two subjects. Na? If all three are below average, then total will also be below average. Okay. What other question? Graded. Anyone has any other doubt, or else I'll start week 4 now.
Ma'am, go
Can
just
you
go to
explain the difference?
first question, ma'am. Just one notation I want to know.
First, this one.
This percent notation which indicate
It is
Modulo
just the
operator.
remainder. Okay,
Modulo
it's the
operator.
modular operator. So if
oh
let's say letter count is 6, so 6 by 2 is what? If you divide 6 by 2, do you get any remainder? Remainder is 0,
It give
right?
only remainder.
But if you divide 5 by 2, then remainder is
Ma'am,
1.
this question was wrong, ma'am. I can't check for the odd number.
This question is wrong.
Yeah, ma'am, I pointed the fourth out. I think,
Rahul, how much you got in this week in graded assignment 3?
ma'am,
Okay,
100, 180.
Let's
question is
start
wrong in
in.
graduated week 3.
Yeah, I have also got that kind of.
Okay, everyone,
Let-
please, if you have a doubt, then only keep your mics on. You can discuss anything else outside of the class.
Ma'am,
Okay, we will
I
start
have
in
a
week 4
doubt.
now. Yeah, just the last doubt I will take right now. Okay, then I
Ma'am,
have
can
to
you
start
please
week 4.
can you please explain the difference between arguments and parameter?
No difference. Both are same thing.
Both are
Whatever
same.
we pass in this function, okay, whenever we call a function, whatever we
No,
pass in
ma'am,
those
function,
parentheses,
not procedure, ma'am.
same thing. When you learn a programming language, you'll know procedure is what we call
Yeah,
function.
ma'am, in further programming, it is
Procedure is
procedure.
what?
Then
That
method is
procedure,
also there.
whatever your. Okay, can I
Method and
finish?
yeah.
Please, everyone will mute. When I will ask someone to talk, only they will talk, or otherwise, if you have a doubt, only then. Okay, we are already running a lot behind. Listen, procedure is what? Like all of these procedures we were defining till now, like is in sequence, all these procedures, we are passing something in the parenthesis whenever we are calling the procedure, right? That thing that we pass in the parenthesis is called an argument or a parameter. When you define the procedure, then you do not use that. You use any arbitrary variable to in place of that parameter just to show what happens, how the procedure is defined, what the procedure is doing. When you call a procedure, then you define the parameter that what you want to pass. Clear?
Yes, ma'am. Ma'am, in the last class, TA class, I have asked the doubt in assignment 3.5 and question number second. Ma'am has told me that the max is defined on the argument, not parameter. These are different things.
Argument and parameter in which question she has said this?
Ma'am, assignment number 3.4, 3.5, question number third.
3.5.
3.5, ma'am.
Question number 3. This one.
Yes, ma'am.
Maximum total is equal to the sum of the maximum marks in 3
No, ma'am,
subjects. What
question
is this
number
question?
2. Ma'am, question number 2, sorry.
Logic used by procedure max to compute the maximum marks depends on the parameter that is passed to it. What is this procedure? I don't know what is the procedure. Procedure max is doing what?
Ma'am, Max is explained in the video, I think.
Yeah, can
Ma'am,
anyone
max
tell
give
me
only the
shortly what max is
integer
doing?
value, ma'am.
Max is providing a true or false.
No. It give only
No,
integer
no,
value.
I don't want to know what it is returning. Just tell me what the procedure max does. What is its function?
It is not asking for max is here just doing things like data type, ma'am. And max only return the integer value. It is
Okay,
asking
then
for this.
just give me some time. I will go through this lecture once and see what this max is about. But as far as you're concerned, procedure whenever you are calling, argument and parameters are the same thing. Okay.
Okay, ma'am.
But still, I will check this once and I'll
It's
let you know
it's
in the next
Boolean,
class.
not integer.
I am not sure. I don't know what this procedure max does. I have to check it once because it's from the lecture. I don't exactly remember what this procedure is about. Okay.
Ma'am,
Let's
I
start
have
week
doubts
4
in week
content
4 activity.
Oh,
later on. First, let us complete the theory because you still have other sessions for week 4 also. At least I need to complete some part. Okay. Is the screen visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Look, first let's get a little overview. What is week 4 content? Week 4 contains mainly binning. Okay, the concept of binning that we will explain. It also has the problem of birthday paradox. What is the birthday paradox problem? I'll just say very briefly. Birthday paradox is a problem where we think that even if we have a data set as small as 25 people, let's say, then there is also still a chance, a 50% chance of finding birthday twins. That is two people having the same birthday. Even in a group as small as 25 people, there is a 50% chance. Okay, even if it seems impossible, still there is a 50% chance. This is the birthday paradox problem. Now, what we deal with is if I have a deck of cards like in the scores data set, how can I find out two people with the same birthday and how can I minimize the number of comparisons? Okay, so if I have 30 cards, what is the actual number of comparisons? 30 people with all 30 people. So 30 into 30 is 900. right? So this number of comparison, how much can I bring it down? Now to bring down the number of comparisons, we use the concept of binning. That means dividing into smaller groups. Okay, instead of doing the iterations among all 30 people at once, we maybe break them down into groups of 6 people each or 5 people each, like this. We will see how that reduces the number of comparisons, but it is a significant reduction. And remember, as your sample set grows, if I have a group of 5 people, okay, then the total number of comparison or pairs of comparison between two people. Okay, if I am comparing two people at once and I have total 5 people in my group, then the number of comparison, whatever it is, total number of comparison, it
n into n
increases
minus 1.
exponentially. Okay, it increases exponentially as your sample set increases. Whatever it is for 5 people, when you check the same for 20 people, it's a huge number. Okay, so this exponential growth we want to bring down. For that, the binning concept is used. Now let's see what is binning. So see, first thing it is written is reducing number of comparisons. This is our goal. Why reducing number of comparisons? So that it takes less time to execute the program. So first thing is, very carefully listen to this entire slide, okay? Some computations seem to require comparisons of each card with all other cards in the pile. Like say, I chose this, right? That's birthday paradox. That means I want to find two people who have the same birthday. So what is the naive way, what is the brute force approach to do this? You pick up one card and you compare that card with every other card, right? This is the naive method to do it. Anyone can do this. And once you match that, you put that card aside, you pick the next card, again do the entire matching with all other cards. This is how we do. Now we observe that if we can organize the cards into bins based on some criteria, some heuristic, okay, then we can significantly reduce the number of comparisons that are required. Then we need to compare cards within one bin only. A simple example of this is in the birthday paradox problem, if we talk about how many months are there in a year? 12 months. So if I have 30 people, their birthdays might be, if the data is a normal data, it is not a skewed data. Skewed means that the data is inherently skewed, like maybe all people have birthdays in same month. So this is a rare occurrence. If the data is not like that, if it is, let's say in general it is a well distributed data, that let's say every month has two or three people having birthdays in it, then what will happen if I organize the cards into 12 different bins based on month? Okay, then only in one single month I have to do the comparison. So this is a better way, because otherwise I was comparing people born in January with people born in December, even though there is no chance of them having the same birthday. But I know that inside the January bin, there is a higher chance, much higher chance of people having the same birthday, right? This is called binning. Now, this binning can be done in like various ways. There can be various heuristics. Like even in this birthday paradox only, one binning can be done by this month. That is 12 different bins I have, 12 different, think of it as like 12 different buckets maybe. Okay. In each bucket, I have, in Jan bucket, I have the cards of all people born in January. Feb bucket, I have all people born in February. Like this, I can do. One more binning I can do is how many how many days are there? 1 to 31. Right? So 1 to 31. I can have 31 different bins. Okay. And I put the people, let's say all people born on the first of any month. Them I put in the first bucket. All people born on the second of any month, we put them in a separate bucket. So that case also the number of comparisons is less. This division of data into smaller buckets or smaller piles will reduce your number of comparisons, because now we have a criteria placed on it, a filter placed on it. This is binning. Is there a formal way of determining the reduction in comparisons? We have to calculate the number of comparisons with binning and without binning. That means if I want to know that how much is this really affecting my time of calculation. So if I don't use binning, if I use the whole dataset as a whole and I do the comparisons, then how many number of comparisons is it taking me? And if I use binning, that is I divide the data into small piles and just do comparisons within each pile, not inter-pile comparison, then how much number of comparisons are there? If I find both these values, I can just get the difference and that will be the reduction factor, right? Is this much clear to everyone? What is binning?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, good. Now we will actually see the mathematical part of it. Okay. Let's say we have 5 elements A, B, C, D, E. Okay. Now I want to compare each element with all other elements. Now simply speaking, we will start with, let's say, A. A is first compared with B. Now remember, a comparison works both ways. If A is compared with B, that means B is also compared with A. These are not separate things, right? A compared with B is same as B compared with A. So we will take comparison between two elements once only. Okay, because A to B is same as B to A. So I'm writing a bidirectional graph. I'm drawing this like a bidirectional arrow. So A and B can have one comparison. I want everyone to be compared with everyone else. Then A and C can have one comparison. A and D can have one comparison. And A and E can have one comparison. So how many comparisons for A?
4.
4.
4. Next come to B. So A is now done. Next we come to node B. So when I start with B, do I need to compare with A again?
No.
No,
A has
ma'am.
already been compared, but I need to compare with C. So one comparison with C, one comparison with D, and one comparison with E. So how many for B?
3.
3. Next we pick node C. B is also done. Node C is already compared with A and B. So we will just compare it with D and E. So for C, 2 comparisons. Next, C is also done. Pick D node. D is compared with everyone except E. So just one edge from D to E. So for D, I need one comparison. Now when I get to E, do I need to perform any comparison?
No, ma'am.
No,
No,
ma'am.
So
ma'am.
what is the total number of comparisons I got?
What
A
is
plus
10.
B plus C
10.
plus D.
10.
Correct. So this is 10. This is the naive approach. Okay. Now see. In all these slides, this thing is only said. Yeah. Let's start from here. So up to this, we are all understanding, right? That number of comparisons is 10. Next, they are saying for n objects. Now we are going to generalize this. Now we are doing for 5 objects. It can be n number of objects. What will be the number of comparisons for n objects? That means, see, when 5 objects were there, then the first was what? 4 comparisons for the first node, 3 for the second node, 2 for the third node, and 1 for the fourth node, and for the fifth element, 0 comparisons. That means 1 plus 2 plus 3 plus 4. So 1 to n minus 1 summation of values from 1 up to n minus 1, where n is 5. Correct? N is the number of objects. When number of object is n and n is equal to 5, then I did 1 plus 2 plus 3 plus 4. That means 1 up to n minus 1, the summation of this. Correct?
Yes, ma'am.
So just place the values if you want, just place the values here. So 1 here. What is n minus 1? N minus 1 is 4. N minus 2 is 3. N minus 3 is 2. Right? This summation we did. Now just generalizing it for any n. If I have 100 objects, then also I will do a summation from 1 till n minus 1, which is arithmetic. What is the formula for this summation of first n natural numbers? N into n minus 1 by 2. Right? This formula, even if you can't remember, you can derive this. Okay, I'll show you the derivation. But for any sum of natural numbers from 1 to n minus 1, right, the formula is n into n minus 1 by 2. What is the formula if I want to find sum from 1 to n?
N into
n
n
into n
minus 1
minus
by 2.
1 by 2. n
1
into
to
n minus 1 by 2.
n, I said. I want summation from 1 to n. This is summation from 1 to n minus 1. What if I want summation from 1 to n? Then how will you change the formula?
N minus 1 into n minus 2 upon
n
2.
into n plus 1 by 2.
Correct. I'll show the derivation. Okay. See. Up to this, everyone is clear, right? This n into n minus 1 by 2. Any
Yeah, ma'am.
confusion till now?
No.
No.
Yes.
Okay. Now see, the same thing I can think of from a combinations perspective. Everyone knows what are permutation combinations. Even if you don't know, this gives the exact same result. Okay. When I write NC2, it means I want to pick any two objects from n objects. Okay. So how many ways can I pick those two objects? This is the number of combinations. So if I write NC2 means total number of objects is n. N is total number of objects. And 2 is what? Number of objects I want to pick at a time. So NC2 describes in how many ways can I pick two objects from n objects. The answer of this is also n into n minus 1 by 2. So why am I using this combination formula? Basically n is what? All 5 n nodes here. So at one comparison, how many nodes am I comparing at once? 2 nodes. So how many ways of picking those 2 nodes? That is n into n minus 1 by 2. This is a combination formula. Okay. But both are exactly same. Now see, if I don't remember this formula, how can I derive it? From first principles, we can derive this very easily. See, first of all, if I have n objects and I want all of them to be compared with all of them, like I had 30 cards in scores dataset and I want to compare each card with every other card, then how many comparisons? 30 into 30. That is the number of total combinations, right?
Yes, ma'am.
Yes, no.
Yes, ma'am.
So if I have n objects, how many pairs can be there in total? N cross n. So if I want to reduce, now tell me, is there any point in comparing A with itself or B with itself? Self comparisons do I need? So how many such self comparisons will be there if there are total of n objects? If I have 5 objects,
Hmm.
no, don't get, I'm just answer this much, that if there are 5 objects, how many self comparisons are there?
5.
5. A with A, B with B, C with C, D with D, E with E. Right. So if I have n objects, how many self comparisons are there?
N.
N. But this is not needed. We are not comparing an object with itself. We are comparing between two different objects. So I have to reduce the number of these self comparisons because n cross n includes these self comparisons also, right? A card is also compared with itself, which I don't need. So you subtract that n from n cross n. So n cross n minus n. Now I can take n common from here, right? If I take n common, then it becomes n into n minus 1 from this expression.
Yes, ma'am.
Yes, ma'am.
But I again said that if I compare A with B, then B with A is also the same thing.
Yes, ma'am.
But when I write n cross n, these are taken as different, what can I say? They are taken as different comparisons. A to B is counted as 1, B to A is counted as 1. But these are to both the same thing. So I don't need to do it twice. So for every comparison, there is actually a duplicate. Like if I have a comparison from A to C, there is also one from C to A in this whole n cross n set. That means I need to divide that total number of comparison by half, right?
Yes, ma'am.
So just divide by 2, n into n minus 1. So first, I'm taking out all the self comparisons, that is n. Next, I know that since I'm comparing A with B, in total n cross n set, there is also a comparison for B with A, but both are same thing. Now this duplicate exists for every comparison. So the total set needs to be divided by half to get unique comparisons, right? So n into n minus 1 by 2. This is how you can get this same formula by first principles. So even if you don't remember, you can derive it, right? Any confusion till now?
No, ma'am.
Anywhere? Okay. See. Now number of comparisons, you can write this as this. Just by 2, it is written as half in front. Okay. So half into n minus 1. This is the same thing. Now this is a very interesting data because here you can see how the growth is so exponential, right? Whenever like your sample size increases, the number of comparisons increases dramatically. So for 2 nodes, if I only have A and B, how many comparisons do I need? 1, right? If I have 3 nodes, I need 3 comparisons. If I have 4 nodes, I need 6 comparisons. You can find this by just putting it in the formula also. N into n minus 1 by 2. But look, when I have 10 nodes, there are 45 comparisons. But when I have 100 nodes, there are almost 50,000 comparisons. And when I have 1,000 nodes, I have like 5 lakh something comparisons almost. So it grows really fast. Now this growth, this exponential growth is what we are trying to reduce. And for this, we have the binning concept. Okay. Look, this is the curve, quadratic curve. See, it is rising. It's a steep curve.
Exponential curve.
Ma'am,
Yeah.
not is
Exponential increasing curve that.
It is an increasing curve. See, it is rising. There are no, there is a peak here, but if I keep on increasing my sample size, then it will keep on rising.
Post
And
infinity, yes.
at one point, it will become almost your parallel to the y axis, but it will never touch. Okay. I don't need to understand that. That's fine. So how do we reduce the number of comparisons? This is the main question. The key idea is to use binning. Now let's say I have 9 objects, A, B, C, D, E, F, G, H, I. Okay. So number of comparisons without binning is how much? N into n minus 1 by 2 or half into n minus 1, same thing. So just do 9 into n minus 1 is 8 by 2. So 72 by 30 by 2 is what? 36. So 36 comparisons without binning. Correct? Now if I do use binning, that means there are 9 objects. So let's make groups of 3. If I made 3 groups of 3, so one is this bin, this is an entire bin, this is the second bin, this is the third bin. Now inside each of these bins, let's do the comparison. Okay, the way of comparing
9.
remains same. So let's compare in the first bin. How many comparisons are there? Let's start with node A. I'm just writing this once, then I'll use the formula. Okay. So if I compare A, then A to B one comparison, A to C one comparison. Correct? So for A, I have 2 comparisons. Then for B, B to C one comparison. For C, do I need any comparison?
No.
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 So total comparison from one bin is how many? 3.
3.
So this same thing will apply for this bin as well as this bin. Right? So
Yes,
3
ma'am.
plus 3 plus 3, 9 comparisons with binning. How much did we
Yes, ma'am.
decrease? By a factor of 4. See, 36 by 9. So a factor of 4 is the decrease in number of comparisons. That's a big factor. That's a very significant factor. Right? Even if you just, instead of doing this, just write n into n minus 1 by 2 because you need to be accustomed to this one. No? So 3 into 2 by 2. That is 3 for each bin. So 3 plus 3 plus 3, 9. And without binning, 36. The same thing is written over here. Okay. Main, yeah, this line I was finding. So the number of comparisons reduces from 36 to 9, which is reduced by a factor of 4 times. 36 by 9. So this is just to show that how binning can improve the quality of your calculation. For n items, now this slide is very, very important. Okay, you can take a screenshot or whatever helps, but please keep this slide with you and go over it again and again because these formulas you need to keep in your mind because every time in exam you won't have the time to derive from the beginning, right? Even though all of these are very easily derivable still.
Ma'am, this slides isn't clear to me.
This slide, yeah, I will explain. See, for n items, okay, for n items, number of comparisons without binning, we are all knowing it is n into n minus 1 by 2. Correct? First point is clear for everybody, right?
Yes, ma'am.
Now I have k number of bins of equal size. Remember, we are always using equal size bins. That means the distribution of data is equal in all bins. Like we had 9 objects, so 3 bins each with having 3 nodes each. So if we use k bins of equal size, the number of item in each bin is how many? Total item n, number of bins k, equal size bins. So total items in each bin is what? N by k. If total item 9 and I have 3
Yes, ma'am.
bins of equal size, so 9 by 3. So n by k. First thing. Next is saying number of comparisons per bin. So now per bin, if I want to find the number of comparisons, like I did previously, What is the formula? Just replace n by k. Instead of n in that n into n minus 1 by 2 in this formula, instead of writing n, you write n by k. Because now your number of items in each bin is what? N by k. Okay. So n is replaced by what? N by k. See, this is the exact same formula. Just instead of n, I'm writing n by k. Because in each bin, I'm doing the comparison. So total number of comparison is what? If in each bin, I have half into n by k minus 1 number of comparisons, and there are k bins, then what is the total number of comparison? This into k. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Anyone is getting confused? Want me to
No,
explain
ma'am.
this again? Anyone?
No.
Okay. See. So total number of comparisons, see, k into this thing. Now, if you just do a multiplication and, just do the cross multiply and everything, then this will evaluate to this. Half into n by k minus 1. Okay, just that this k is getting cancelled with this k. That's all. So half into n by k minus 1. So I am asking you to just remember this formula instead of deriving it every time. If you can remember, it's a good thing. If you have time, you can derive it. So half into n by k minus 1 is the total number of comparisons when there are n objects and k bins of equal size. Remember. What is the factor of reduction? So last time we saw what? What was the factor of reduction? 4. How did we get it? Number of comparisons without binning by number of comparisons with binning. Right? This is the formula. So what is the number of comparisons without binning? N into n minus 1 by 2. This first one. So put that in the numerator by number of comparisons without binning is what? This one. Now once you solve this, you will get this expression. N minus 1 by n by k minus 1. This is the factor of reduction. That means in the previous example, the total number of comparisons for n objects without binning was 36. And this total number of comparison with binning was 9. So 36 by 9 was 4. So for that example, this n minus 1 by n by k minus 1 value evaluated to 4. Right? So for n equal to 9 and k equal to 3, you can check it for yourself. It will give 4. So reduction is by 4 times. Is this slide clear now?
Yes, ma'am.
Yes, ma'am.
Ma'am,
Yes, ma'am.
ma'am, can you repeat the cases of with binning and without binning?
See, without binning, in that previous example, we saw there are n objects or 9 objects, let's say. Then what is the number of comparison without binning? Just the naive approach, n into n minus 1 by 2. Right?
Yes.
So 9 into 9 minus 1 by 2, that is 36 it was giving. Now if I bin the objects in equal sized bins, like here we saw, here. Now 9 objects are binned. This is the first bin, second bin, third bin. Right?
Yes.
So now we are comparing inside each bin. So after doing these comparisons, we found out that what is the total number of comparisons? Okay, let's write it as the formula told us. So if I have n by k objects in each bin, are you agreeing that there are n by k objects in each bin? 9
Yes,
by
ma'am.
3. Okay. That means what is the number of comparison within each bin? Half
3.
into n by k into n by k minus 1. Right? If you solve this, this will give what? 3 for this example. And there are how many such bins? What is k? 3. Right? So 3 cross 3 is what? 9.
9.
This 9 is what? Total number of comparisons after binning. So what is the factor by which you just reduced number of comparisons?
4.
That formula is number of comparisons before binning by number of comparisons after binning. This is the formula. So 36 by 9, that is 4.
Yes, ma'am.
Clear?
Yes, ma'am.
Same thing is just shown here. Just instead of writing this 3, 9, a bunch of variables are there. Just n and k. These are the only two things you need to remember. N is total number of objects. K is the number of bins of equal size in which you are distributing the objects. Any question till now? Anyone? Any question?
No, ma'am. No question.
Okay.
Ma'am,
So
can you
this
please
summary, yeah.
complete first?
No, nothing important. Tell me.
Oh, ma'am, if you go to the activity 4.3 last question and 4.4, then our concept will be
I know, I know.
more
Yes,
clear.
I will take all those questions. Okay. I'm just asking one last time. Just look at this summary slide. You are asking that question at 10 to the power 8 number of comparisons in 1 second a computer can
Yeah,
do. Yeah.
absolutely.
Yeah, I'll take that question. See. Number of comparisons between all pairs. So what did we learn? Just a quick summary. Number of comparisons between all pairs grows quadratically. Okay. That is quite fast. The curve was very steep. Then the formula of number of comparisons for n items is what? N into n minus 1 by 2. This is important. Sometimes it is possible to find a heuristic that allows us to put items into bins and compare only items within the bins. Now, this cannot always be the case. Okay. It depends on your data, whether you can group them or not. Like in case of the birthday paradox problem, we can group them by birthday months or by days. But this will not be true in every case. In every data, you cannot do binning. Okay, because there has to be some criteria also. Now, if you can bin the data, then if there are n items put into k bins of equal size, then the number of comparisons reduces to what? Half into n minus n by k minus 1. Where did we get this formula from? Just that simple formula, k into number of comparisons in each bucket. That was n by k into n by k minus 1. This, if you solve, you will get this. So what is the factor of reduction? Total number of comparisons, that is this, by this, and just solving this, you will get this formula n minus 1 by n by k minus 1. This is all. Okay, now let's take some activity. Can you see the portal?
Yes, ma'am.
Yes, ma'am.
Okay. See activity 4.3. Okay, let's start with this one. Let's start with the third question. It is saying, if you have gone through this lecture, you will know that professors were saying that if a computer, if a computer can do 10 to the power 8 comparisons per second, let's say that is the speed of comparison. Okay. And if there are a total of, let's say, 5 elements are there. Okay. And it can do 10 to the power 8 comparisons, then that is a very good thing, right? It will do it very fast. But what if 5 into 10 to the power 8? Okay, what if 5 into 10 to the power 8 number of comparisons are there? Then how many seconds will your data take?
5 seconds.
5 seconds.
5 seconds.
5,000.
But 5 seconds is a long time. In computer language, it is a very long time, right? Where we work with nanoseconds, microseconds, 5 seconds is a very long time. We don't want to wait for that long. So this
Then
question
5,000
particularly,
seconds.
yeah, this question particularly exactly. So 5,000 seconds, how did you get?
Time
Who
equal
want
to
to
number
explain?
of comparison upon comparison.
So how did you get the total number of comparison? What formula?
N
Anyone
into
wants to
n
try
minus
this?
1.
By 2, right? So they are saying that there are 1 million elements. So n is 1 million. That is 10 lakhs. Okay. Now, how many seconds will it take for the computer to do pairwise comparison of 1 million elements? So you can understand that if number of elements is only 10 lakh, then how many number of comparisons will be there? It's a huge number. It will be 10 lakh into 10 lakh minus 1 by 2 without binning. Correct? Yes or no?
Yes. Yes, ma'am.
So just calculate this thing. 10 lakh into 10 lakh minus 1 by 2. This is your total number of comparisons. By 10 to the power 8. This will give you the number of seconds that it will take for the computer to do that calculation, which will be 5,000 nearly. Okay, just do this comparison, do this calculation once, anyone. So this question is clear how we are solving?
Yes, ma'am.
Yes, ma'am.
Okay. So I have a calculator. This is just for 2 seconds. This will take. So Consider the following 7 elements. Let's take this question also. Let's just discuss all the activities, okay? Then I have 1 or 2 more concepts from this week which I'll tell you. Let's do the other questions here. So there are 7 nodes here. If we connect each element with every other element by lines, what is the total number of lines that we would have to draw? So line means what here? Basically comparison, right? Line is comparison. So if there are 7 elements, how many comparison do we have to do? N into n minus 1. So 7 into 6 by 2. That is
Yes, ma'am.
21. So it should be 21 lines here. Right. This one is nearly 5,000 seconds. Now the first question is very easy. It is asking, we have n cards in a pile. We compare each card with every other card exactly once. What is the total number of comparisons? We all know it is n into n minus 1 by 2. Right. Still, let's just check the answer once. Okay, all of these are correct. Any question from 4.3, anyone?
No.
No, ma'am.
Ma'am, can you please explain question number 2?
2 is nothing. See, it is saying there are 7 nodes. Okay. So 7 elements. N is 7. It is saying if we connect each element with every other element by lines, just like we drew when that
Okay, it's
5
like
element graph I was
A
drawing.
to E.
Yeah, like A to B, A to C, A to D. That means A is compared with B, A is compared with C, A is compared with D. So lines here is nothing but another word for comparison. Okay, so every element is compared with every other element. So what is the total number of comparison? Instead of writing comparison, they have written lines just to throw you a little. Okay, but the formula remains same, n into n minus 1 by 2. So 7 into 6 by 2 is 21. Okay.
Ma'am, after doing the calculation, half into 10 to the power 6 into 10 to the power 6 minus 1, the answer is given 4.99 into 10 to the power 11. And we can assume that 4.9 as 5.
Yeah,
5
that is
into
why it is written nearly 5,000 seconds. It's not exactly.
It will never give 5,000 exact value.
It will never give 5,000 exact value because
5
this is
into
a fraction.
5 into 10 to the power 11. And after that, we have to use unitary method.
You have to divide it by 10 to the power 8 also.
10 to the power 8.
Yeah, because in each second, how many comparisons are being done? 10 to the power 8.
Yes,
So
ma'am.
this is your total number of comparison, n into n minus 1 by 2. So divide it first.
In each second,
Per
there is.
second we are calculating.
Yeah, the data given to you is in 1 second, you can do 10 to the power 8 number of comparisons. Now you have 1 million objects. So 1 million into 1 million minus 1 by 2 is your total number of comparison. Divide that by 10 to the power 8. That will give you how many seconds it is taking.
Yes, ma'am, it's clear now.
Yeah. So activity 2 also, let's solve this quickly. What are the possible binning strategies to find pairs of students of same date of birth? I already gave you the answer to this. Tell me which
First two
option?
options. First two options.
Month of birth.
First two.
Second.
Because birthday is defined by month and day, nothing to do with city, town, or total marks, right? Second, if a bin has at most 1 card, then there is no need to iterate that bin. True or false?
Ma'am.
True.
Ma'am.
If only 1 element is there, who will you compare it with? So no need to iterate. 1 iteration is sufficient to bin the cards. That means if I want to group the cards, let's say I have 30 cards, I want to bin them by date of month, month of DOB. That means the month in which students are born. So just by going once through the entire pile, I can make small piles of for every month. Is that possible?
Yes, ma'am, it's true.
So this is true. We can solve birthday paradox problem after binning in 1 iteration. Is this true?
False.
No,
Yes,
ma'am,
ma'am.
false.
Why it is false? Because inside the
Then
bins we also have to
We have
iterate,
to
na?
do the iteration.
So it is not 1 iteration. So
Yes,
sorry, this
ma'am.
is false. What is the advantage of binning?
Ma'am,
Reduces
it
the number
reduces
of
the number of
comparisons.
comparisons.
Number of comparisons.
Great. See, you got full marks. Now, activity 1 also let's do, and then I have a new concept. Oh, this one I have solved, I think. Okay, anyway. We can always find at least 1 pair of students with same date of birth in a single iteration. Is this true? Is
No,
it
ma'am.
always true?
false.
There is only
No,
a
no.
50% chance, right? Only a 50% chance that birthday twins exist in a data set. So it is not true. We cannot say for sure that there will be one such pair. Mute, please, whoever that is. Okay. Next question. Two nested iterations are sufficient to find pairs of students with same date of birth. Correct?
Yes, ma'am.
Because outer iteration you pick one card, inner iteration you compare it with all other cards like this. This third question, see, there are three statements given. Student X is compared with another student Y from pile 1. Repeat statement 1 until pile is empty. Date of birth of student X does not match with any other student in pile 1. Okay. Then based on the above statements, which is the correct thing to do? Should we
Both X,
discard both X and Y?
both X and Y, we can discard.
Yeah.
Why?
No, ma'am, we
Why
can
will you discard
discard
Y?
X and keep Y.
See, I can discard X, but I have to keep Y because Y hasn't been compared with every other card. Y was only compared with X. X is compared with every other student, right? Y is just one such card with whom X was compared, but X was compared with every student. So Y might still have a birthday twin with some other student, right? So you cannot discard Y, you can discard X. Clear why we are keeping Y?
There's only one among many.
I don't think everyone understood this question. See, first of all, X is, let's say, one card that I pick, okay, from the scores data set. I want to know if this person has a birthday twin, if someone has the same birthday as this person. So I have to compare it with all other cards, right? Now, Y is just one student with whom X was compared. Then it didn't find a match, so I moved on, I picked the next card. So at the end, when pile was empty, I have compared with all cards, X still did not find a match. So I can surely say that X does not have a birthday twin. But can I say that that one student Y, he also doesn't have a birthday twin?
No, ma'am.
No, ma'am.
For Y also I need to do all the iterations then, other than X, right?
Yes, ma'am.
So I have to keep Y for further iterations, but I can discard X. Okay.
Ma'am, please explain question number 2 again.
2 is what? It is asking two nested iterations are sufficient to find pairs of students with the same date of birth. So how do we find pairs of students with same date of birth? What is the naive approach first? You pick one card and you compare that card with every other card. So there is
Yes,
an
ma'am.
outer iteration and an inner iteration, right? Outer iteration picks one card, inner iteration is going to compare it with every other card. I would say that just go through lecture 4.1 once, okay? Then it will be clearer.
Okay, ma'am.
But ma'am, I also have doubt in this. Like, they're saying two nested iterations. It might take more than two to find pairs.
It is asking that is it sufficient? 2 is sufficient.
Just
With
like
2 you
That means
can
it
find.
might. Okay, that means it might take more, but we can say that two is sufficient.
You
We might
can do
find.
it you can do it using more than 2 iterations. Okay, if you want. But 2 is also sufficient to find all such pairs.
Okay, ma'am.
It will be better understood if you just watch this lecture once, okay? It's very well it is very
Yes,
well
ma'am.
described.
Actually, I watched, but I was not able to understand this particular question.
See, it is just saying that 2 is a sufficient number. Now, this type of code you can write in a lot of different ways. You can do binning, you cannot do binning. It all depends on what process you choose to do. But two nested iterations are enough to find all such pairs because then you are going
Yes.
through all the pairs, outer
Yes.
iteration and inner iteration.
Understood, ma'am.
Now see, now one more
Uh,
concept I'm going to tell you.
Ma'am, for activity 4.4 is the exact questions content which concept you have understand us. These questions.
Yeah, right. Okay, let's take this. So assume that we have 20 objects that need to be compared. Okay, so n is what? 20. How many pairwise comparisons do we need to make if each object is compared with every other object exactly once? Anyone wants to try? How many
190.
pairwise comparison?
190.
How do you get 190?
Ma'am, we will use the formula
N into
half
n minus
into
1.
n into n minus 1.
Correct. So 20
Yes,
into 19 by
190.
2. So 190. This is very simple. 190. This is the last activity I'll do today. Okay, I have to finish the concepts. So assume that we can distribute the 20 objects into bins of equal size. If we go with 4 bins, how many comparisons? So 4 bins means each bin having how many? 5, right? So inside each bin, how many comparisons? 5 into 4 by 10, 2. That is 10,
Ma'am,
right?
40. I said
40,
40.
So
40,
10
ma'am.
plus 10 plus 10 plus 10, 40. Third is we distribute
Excuse
20
ma'am.
objects into, yeah.
Ma'am, I'm sorry to disturb you, but are you going to discuss the practice assignment today of fourth week?
No. Practice is tomorrow. Okay.
Okay.
You sir will discuss.
Okay.
Even the concepts are not done. So after that only I'll take practice. Okay. So we distribute 20 objects into bins of equal size. How many bins should we choose to make the least number of comparisons overall? Any idea?
30.
Ma'am,
How many?
I think the answer should be 20 if we
Correct.
didn't pick any
Because
card,
if we individually put one card in each bin,
each bin.
then it won't take any comparison more than 20.
So the comparison will be 0.
There will be 0 comparisons because inside of each bin you have nothing to compare. There is only one card. So this is 20. This is the highest number of bins that you can take for least number of
Ma'am, the
comparison.
answer is 10.
Ma'am, but there should be something to compare.
Yes, ma'am.
One second.
Yes,
This
ma'am.
is for how many bins we should choose to make the least number. No, there should be some comparison. No?
Oh,
So 20 objects. So at least 2 objects in each bin. So 10. It should be 10. 10
Yes,
bins.
ma'am.
At least 2 in each bin. Otherwise, we are not even comparing. No data we will get out of that. So 10 bins, 2 objects each. Then how many comparisons are there? 10 comparisons. Right? That is the least number. Based on questions 1 and 3, what factor does binning reduce the number of comparison? 19?
19.
19.
We want to find number of pairs of students who satisfy both the conditions given below. Both students in the pair have same total marks and both students do not belong to same gender. So we want number of pairs of such students who have same total marks but from opposite gender. Now divide the students into 2 bins, one of which contains boys and the other which contains girls, and perform pairwise comparisons within the bins. Will this approach give you the correct answer? So you are never comparing between 2 separate genders, right? But your criteria is that both of them cannot be from the same gender. So is this correct?
No, ma'am.
No, ma'am.
A better way would be to bin according to different total marks, right? Let's say people have scored total marks like 200, 250. So there should be a bin called 200, inside which all the people are there who have scored marks 200. There you can make the pairwise comparison, that is there a girl and a boy in that bin. That means they are one pair, right? Same total marks but different gender. This approach will give you the answer. So this is wrong.
No.
6 is what we have data about birth dates. Year, month, date of 100 people in a room. We wish to find the number of pairs of people who are born in the same year. So which is the best binning strategy? We want year, same year. So first option is use 12 bins, one for each month. So if I do
Yes.
month wise, is this the best?
No, ma'am.
Second is asking we use 2 bins, one for people born before the year 2000 and another for people born on or after year 2000. Is this best?
No, ma'am.
No, ma'am.
Third option is the best. Why? Because there is a bin for each decade starting from 1900. Because if we use only 2 bins, then we are not significantly reducing the number of comparisons. 2 bins are still a lot of comparison. As you increase number of bins, number of comparisons decreases. Right? And what is the binning criteria? It should not be based on month. It should be based on year because we are interested in year here. So third option is the correct one.
Ma'am, what about 12
ma'am.
What about 12? Which option?
12
Ma'am,
is
this
month,
option is
12
12
months in a
beans.
year.
How we get 12 beans?
Yeah, so it is saying that one for each decade starting from the year 1900. Now, how many decades have been there from 1900 to 2024? 12 decades.
Yes, ma'am. Acha. Got it.
Okay. So one bin for each decade. Now, concept of fair teams. Has anyone gone through this lecture 4.5?
Yes, ma'am.
If you go through this, you will see it means that actually here we are trying to find two such students who can mentor each other. Like, when can a student mentor another student in a subject? When that student has scored more marks than that student in that subject, right? So we are
Yes, ma'am.
trying to find people who have the similar total marks, but let's say two students have scored 250 as total marks. Okay. Now one of them has a very good score in math but very poor score in physics, and one of them has a very poor score in physics, a very poor score in math but very good score in physics. But they have the similar totals because it is balancing out. Let's say both of them did well in chemistry. So these people, one of them can mentor the other in math and the other can mentor this one in physics. Right? This is the concept of fair teams. That how can I find such pairs of people who are perfect to mentor each other? Now, obviously, I won't, if I have got 40 in physics and someone has got 45, I don't want to be mentored by that person. I would rather be mentored by someone who scored 80 in physics, right? This is the concept. Now, if I solve the activity, it will be a little clearer. Actually, in this week, it is better, I would say, to go through all the lectures once, okay? Because there are very small concepts like fair teams. Then there is one more called this pronoun and proper noun. Okay, I'll tell you what is that pronoun proper noun thing. Let's first solve this activity quickly. We have two students X and Y who satisfy the following condition. That is, their total marks of physics and maths are same. Total marks, sum of marks of physics and maths for X is equal to sum of marks of physics and maths for Y. So which scenario is possible? In the first option C, if X has scored greater than Y in both maths and physics, then can their scores be equal, sum of scores? Then obviously X has a total greater score than Y.
Yes, ma'am.
So it is not possible. One scenario is that X and Y have scored equal in both physics and maths. This is possible, right?
Yes, ma'am.
This one is saying X has scored greater than Y in math but less in physics. This is also possible.
Yes,
Yes,
ma'am.
ma'am.
And the last option, that he has scored less in maths than Y but greater in physics. This is also possible.
Yes,
Yes.
ma'am.
Okay. See. Next question is saying we wish to count the number of students in the bin 201 to 225 endpoints included. If I say endpoints included, that means 201 to 225. How many different digits are there? 25. Correct? I'm
Yes, ma'am.
just saying this. It is not important for this question, but people are very confused when I say endpoints included, endpoints excluded. Endpoints included means 201 and 225 are also being counted. So we wish to count number of students in the bin 201 to 225. This is actually total marks. Okay, if you go through this lecture, you'll see it is based on total marks. So people who have scored total marks between 201 and 225 and stored the result in a variable A. Okay, so A will contain count of number of students who have scored total marks in this range. Which of the following conditions checks if a card X falls in this range? Okay, so A is already initialized to 0, let's say. Here I've marked the options, but still, let's see. Why is this first option wrong? Anyone can tell me?
Ma'am, A is equal to 1. Ma'am,
A is
we
not
have to
getting
increment.
incremented.
Yes, ma'am.
Correct. Otherwise, this comparison criteria was all right. Okay. Why is option C wrong?
Ma'am,
Because like
this
endpoints
Only
here
less
are
than.
included, but
Endpoint is excluded here.
Is the endpoint excluded? See carefully.
Ma'am, the
hmm,
range is not correct.
Oh, range is not correct. It's 200 and 226.
201
This
is
is
No,
included.
it's
incorrect.
actually it's less.
Ma'am,
It's less than it's greater than 200, which means 201 is there.
And also it is
So,
less than 226, which means 25 is obviously
see,
there.
you assumed that I marked the correct options. You
See,
didn't check
this
for
is correct.
yourself.
Oh,
Okay, this I do. I do this thing every time, and every time people do this. They just assume that I have marked the correct ones. Why? You check for yourself, na? Is this a wrong option? 201 and 225 are both included in this range.
Yes, ma'am. It is correct option.
Yes,
So
ma'am.
it is a
Third
correct
one is
option.
correct.
Is the
Fourth one
second
is wrong.
option correct?
Yes, ma'am.
Second option, is it correct? Yes.
Yes.
Yes, ma'am.
yes, correct.
What is the fourth option? It is saying if x dot total is greater than 200, greater than equal to 201. Then in nested iteration, it is checking if it is less than equal to 225. Then I'm incrementing A. Is this correct or wrong?
Correct, ma'am.
It is
Correct.
correct.
Yes, ma'am. It is correct.
So all of these are correct. Next we have consider arbitrary team represented by XY. So there is a procedure given to you, is left heavy. This procedure is called is left heavy. And we are passing two cards, X and Y. Okay. So these are what arguments or parameters, M and N. So if M total minus N total is greater than 0, then return true, else return false. So M and N are basically two cards of two students. You can think of them as X and Y. Okay. So when we call the procedure, we call them by XY. So is left heavy, this if it returns the value false, then which of the following scenarios are possible? If is left heavy, XY returns the value false. When will it return the value false? When X has a lesser total than N, that is when M total minus N total is not greater than 0. This will happen when X has a smaller total than Y. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
So two scenarios are there. Just a second. Yeah. So this procedure will return false in two scenarios, right? If I pass, instead of M and N, think of it as X and Y. Now, two cases when this procedure will return false. When Y total marks is greater than X total marks, and when both of them has scored the same total marks. Because the
Yes, ma'am.
condition is for true is what? Greater than 0, not greater than equal to 0. Right? So both X and Y have scored the same total, and total marks of Y is greater than that of X. So both are correct options. Next, the return value of is left heavy xy is always the opposite of return value of is left heavy yx. Is this true? If one returns true, the other will always return false.
No, ma'am.
For which case?
Ma'am, when they both are equal.
Exactly. So when they both are equal, x and y, then whether you pass x first then y or y first then x, whatever the order, it will always return false because it will always be equal to 0. So for that, this is not opposite value, right? So this is false. Now this
Ma'am,
last one you
please
will
explain
solve.
again.
See, it is saying the return value is left heavy xy is always the opposite of return value is left heavy yx. Let's say some person has scored, some person x has scored 200 as a total and y has scored 300 as a total. Okay. In this case, is left heavy procedure will return true or false. 200 minus 300 is what? Less than 0, so it will return false. But if I enter this data in opposite order, 300 comma 200, then it will return true because it is greater than 0 then. 300 minus 200. But what if both of them have scored the same marks? What if both of them have scored 200? Then so it will always be 0, na? Equal to 0. So no matter in which order you are passing x and y in the parameter, it will always return false. So this statement is false. Understood? Yes, no,
No, ma'am.
no?
Ma'am,
Yes,
once
ma'am.
again,
No, ma'am.
Understood. Yes.
X and Y are equal.
Understood.
Just for one case, this is true when x and y are equal. In every other case, this will be false. Okay.
Ma'am, please
That
explain the
means,
other
I guess
cases.
if it is true, it should be true for every situation.
yeah, this is saying that, see, order in which you put the parameters, that is very important, okay, in this type of questions,
Yeah.
since there is a subtraction here. So if I have x as 200 and y as 300, if I pass 200 comma 300, then the subtraction result will be what? In negative. So this will go to the else part and give false. But if I enter it in the opposite way, 300 comma 200, then the difference becomes positive 100, which is greater than 0. That will return true. But what if both of them are equal? What if both are 200? Then in both cases, no matter in which order you enter the values, both values are same. So it will always be equal to 0 and this will always be returning false, right? That's what it is saying. That return
Okay,
value
okay.
is not
Since it
always
is
going to
failing
be
for one
opposite.
condition, we are okay.
Yeah. So it is not always true. That's it.
Yeah,
This
correct.
question you will
Yes.
solve. Okay. I won't tell you the answer to this one. First you try. If you can't solve it, then you ask me in the next session. I won't give the answer to this. Everything if I solve, you won't learn anything.
Madam, explain concepts, ma'am, tomorrow.
Yeah, just one more question let me take, then I will explain the concepts. Okay, just this question let's solve. Same birthday XP. It is a procedure that accepts a card X and a pile P of card as parameters. So pile P, that means an entire pile is coming in your parameter, and X is a single card. It returns the value true if at least one person in the pile whose date of birth matches with X. That is, if one person has the same date of birth as X in the pile P, then it will return true, otherwise it returns false. Okay. Also, the procedure returns the pile in exactly same way that it was passed. So at the end of the procedure also, we have the exact same pile that we passed. Pile P does not change. This is the code. Okay. Two missing statements are here. You have to say which are the correct choices, ideal choices for these statements. So what is given is there is a while loop which is iterating through all the cards in the pile P, and found is some variable which we are checking whether it is false or not. When will found be true? When we find one person whose date of birth matches with X. As soon as we find that person, we set found to true and the procedure ends. Okay. So while more cards are there in
Okay.
pile 1 and found variable is equal to false. Pick one card from pile 1, read it, move it to pile 2. Now you call
Ma'am,
the
here,
procedure if.
here found is
Ask.
equal to false, ma'am. It is not assigned to false. I think found
That
value
is
will
that
not
is what you have to do. That is what you have to do in statement 1,
Yes.
which is missing. First assign the value false to
Yeah,
found.
ma'am. Yeah.
Okay. Then you can check. Now after you read card X, you call this procedure if same birthday X comma pile 1. This procedure returns what? This procedure will be true when there is a person whose birthday is same as that of X, right? So if this procedure returns true, then some statement is here. So what should be this statement 1 and statement 2? Statement 1 I already told you found should be initially set to false. What should be statement 2? If we find a person whose date of birth is same as X,
Found.
Found is equal to
We will
true.
reassign the
found
found
is set to true,
equal to true.
right? That is the
Yep.
answer. Okay. So activity 4.7 only is left. Only one question is there. Okay, let me just give you this concept of what is resolving pronoun. Then we can solve that one question. So
Ma'am,
resolving pronoun.
Excuse me, ma'am. Ma'am,
Yeah.
I want to ask something. Like for each and every card.
Mm.
So, ma'am, that means for each and every card, every time we'll assign the value false to find its pair from the pile. Every time it needs to be assigned false. Like when we have a new card.
See, where is the while loop? This is the while loop bracket. So every
Yes.
time you pick a new card, okay, every time you pick a new card, found once it is set to false. Okay, after that, this condition will not be true. Actually, once you find a match, then you are going to get out of the while loop because this while loop will never be true again. Because the while
Yes,
condition is
ma'am.
what?
That's
While
what.
there are more cards in pile 1 and found is false. Found will never be false again. That's the statement outside of the loop, statement 1.
Yes, ma'am. Actually, that's what I was trying to ask. That once it is true, then it cannot
Yeah,
be
then it has to
false.
stop. See, that is written here. The procedure, it has to be written somewhere. Uh, yeah, the iteration terminates as soon as such a pair is found. See, this one. Okay,
Yes.
this line is important. Okay, so what is this procedure to resolve pronoun with its equivalent matching noun? Okay, I'm just going to tell you briefly what this is. Remember that paragraph words data set that we have, right?
Yes, ma'am.
So in those words, so if I read the cards in a order, it forms a meaningful sentence, right? Now in that sentence, some card might have a proper noun and some card might have a pronoun. Okay. Let's say our statement is, I'm just taking an example. Let's say Rahul is a boy, he is 10 years old. Okay, these are two separate sentences. Rahul is a boy is the first sentence. He is 10 years old is the second sentence. What is the pronoun in these two sentences?
He.
He is the pronoun. Now, when you see this pronoun, how do you know which proper noun is it relating to? That means for which proper noun am I using this pronoun? So the idea is that even though this is not foolproof, okay, but the idea is that wherever you find a pronoun, you backtrack the cards. And the first proper noun that you stumble across while you backtrack, that is the noun that this pronoun is relating to. That is, if I read this like this, see this slide. See, I'm just writing it here only. Let's say, can you see the where I'm writing?
Yes, ma'am.
Okay, this is the
Yes, ma'am.
first. This is the first sentence. This is card 1, card 2, card 3, card 4. Then he is 10 years old. Okay, card 5, card 6, and so on. So card 5 is where we find the pronoun he. So how do I know that which he is this referring to? Who is this he? What is the proper noun? So you just backtrack. What is the last card before that? Boy. Is it a proper noun? No.
No, ma'am.
Is this a proper noun? It's a
No.
article. This is a
No.
verb. Then we come to
Art.
Rahul. Is this a proper noun? Yes.
Yes, ma'am.
So we can say that the first proper noun that comes when we backtrack from the pronoun, that is the proper noun that this pronoun is relating to. But this is not always true. Okay. Let's say if I write a sentence like this, Rahul is taught by Mr. Roy. He is a good student. Okay. So here he is this pronoun. Now try backtracking. The last card is having Mr. Roy. Is this a proper noun?
Yes, ma'am.
But
Yes,
is
right.
this he relating to this proper noun or this proper noun?
Ma'am, Rahul.
So this is not a foolproof method. Okay. It will not always work. In this type of cases, it will not work. But this is how we will do in this course. Okay. So just go through that one lecture 4.71 if you want. There are also more examples that professors have taken. But there is only one question that comes in the activity for this. Let's solve that. And it's actually very interesting. If you go through the lecture, it's a very nice concept. See, it is saying screen visible portal.
Yes.
Yes, ma'am.
Ma'am.
So
That
does
is.
the paragraph words dataset provide the information of personal nouns or pronouns to resolve pronoun with its equivalent matching noun? So is there any information given as such that which pronoun is relating to which noun in the dataset itself?
No,
If it
ma'am.
was
No,
given,
ma'am.
then there would be no need for us to backtrack and do all this, right? It is not given, that's why we are doing this. So it is no. This is the only question that is from here. So we have pretty much covered all the activities and all the lectures. Tomorrow's session, Piyush sir will take up the practice assignment. I'll ask him that. Okay, if
Ma'am,
you
I want
have any
to
more
ask a
doubts.
question.
Yeah.
Ma'am, the concept that are taught in lectures, where is the pseudocode of it? Ma'am, like birthday paradox pseudocode.
Those pseudocodes are actually not given in the supplementary contents. Okay, those are not present in those slides. Are actually so Madhavan said is I think he wrote some pseudocode for this birthday paradox. No? I don't exactly remember, but I think there was some pseudocode for that. So in the supplementary contents, that is this one other slide which is available to me, 4.8. But that is just a summary. Okay, that doesn't have all of these. Let me check once. Yeah, no. Pseudocodes for birthday paradox is not there. Actually, it is not needed that much, the pseudocode for this exact problem, but still, if you want, I mean, understanding it is fine. But if you want, you can just take it from the lecture, like you can note it down, okay? Because the pseudocodes itself are not available. These are slides that the professors themselves used. So these are not available for us. Okay.
Ma'am, professor did not told that this is the pseudocode of birthday paradox or team.
So
Ma'am,
which
team.
lecture is this from, which you're asking?
Ma'am, I am
For fair
asking.
teams and all. Okay, okay. You are saying that those cards that professors are arranging in different ways for different problems. So if there is a pseudocode version for that, that's what you're asking, right?
Yes, yes, ma'am.
No, that is not available actually. So those, see, actually why that is not there is because what they are doing is they are starting from the naive approach. They are doing the most basic thing first. Like for birthday paradox, first we did the complete iteration, that is comparing with all cards instead of binning. So all these pseudocodes, these are not needed. These are just for you to learn the concept why we need binning. Okay. Pseudocodes actually, whatever is present in the question, even you see in these activities, there are not much pseudocode for this week. But when you solve the graded assignment, also you will see that this week is more conceptual than pseudocode based. Okay.
Okay, ma'am.
From the next weeks, when we start after your quiz one, when we start week 5, list, dictionaries, all these things come, then pseudocodes will be there. Lot of pseudocode. Okay.
Okay, ma'am.
So any other question?
Yes, ma'am. Ma'am, like the questions in the activity 4.5, question number 5, it is there are two else blocks. So when will the second else block run?
Which activity? 4.5. Activity, which one did you say? This
Ma'am,
question?
4.5, question number 5, when will the
Wait,
second
wait. I'll share the screen once. One. This one. This I won't solve today. You have to solve this yourself.
Ma'am, I
I'll
am
just tell
asking
you what is happening. See,
when will second else
there
block
is
run?
second else block. That means this last return false when you will reach here. That's what you're asking.
Yes, ma'am. When will this code run?
When the outer if is wrong, that is left heavy is not returning false. If it is returning true, then you come to the outer else.
Okay, ma'am.
Okay. Yeah. Anything else?
Ma'am, your next session will be held on the Friday also.
I am not exactly sure. It could be on Monday. Once, let me check. I think it's on Thursday. Actually, next week we are doing quiz one revisions and mock and all that. So I think my session is on Thursday. Yeah.
Okay.
So Monday, I think Piyush sir or Nalini is going to take. Mine is Thursday. Okay.
Mhm.
All right. If you don't have any more questions, then let's wrap up. Thanks for joining, everyone. Have a good night.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you, ma'am. Good night.
Thank you.
Good night.
Thank you, ma'am. Good
Thank
night.
you, ma'am.
Thank you.
Thanks.
Thank you, ma'am.
Thank you, ma'am.
Thanks.
Thank you.
Thank you, ma'am.
Yeah.
Anthony.
Thank you, ma'am.
Bye bye.
ఇయర్ ఫోన్స్ బండి కావడం మర్చిపోయాను అనుకోండి ఫోన్ చేస్తాను లేదా తీసుకెళ్ళాము తెచ్చావా కర్మమ్మ ఎందుకు తెచ్చాను చెరుకు 200 తెచ్చుకున్నాం ఓకే ఇయర్ ఫోన్స్ తెచ్చుకోవాలి 12 దాకా బయటకు పెట్టుకోండి తర్వాత నేను 2 బన్నీలు 200 తెచ్చుకున్నాను మాకు